Sure. Ladies and gentlemen, please stand up. Ladies and gentlemen, please stand up. We welcome our distinguished Rector of University of Jember and the Dean of Faculty of Medicine of University of Jember. Ladies and gentlemen, please be seated. Thank you. Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya dan salam kebajikan bagi kita semua. Dan salam agromedis. Good morning, the Honorable Dr. Insinyur Iwan Taruna, Magister of Engineering, Insinyur Profesional Madya, as the Rector of University of Jember. The Honorable Dr. Ulfa Elvia, Master of Health, Plastic Surgery, Aesthetic and Reconstruction Specialist, Burns Advanced Subspecialist Consultant, as the Dean of Faculty of Medicine, University of Jember. And welcome to our distinguished guest, Dr. Nur Adiba Mohidem from University Science Islam Malaysia. Dr. Al-Munawir, Master of Health, Doctor of Philosophy from University of Jember. Assistant Professor Atira Nandakumar, Doctor of Philosophy from Kagoshima University, Japan. Associate Professor Dr. Wadasit Sriwong, Doctor of Philosophy from Chulalongkorn University, Thailand, who have kindly joined us via Zoom meeting right now. And the deans, the head of the working units, and representative of the faculties in University of Jember, our treasured lectors, staffs, and students of Faculty of Medicine, University of Jember, and also all participants and the audience that have joined us in the venue or via Zoom meeting. And we inform you that this conference has live in our YouTube channel, Agromedis TV. Good morning and welcome to today's event, Society 5.0, a new challenge and opportunity to agromedicine. Well, ladies and gentlemen, let me introduce myself. My name is Gita Penausa as the Master of Ceremony in this event. So before we start our agenda, let me deliver the structures of the event today as follows. First, the opening. Second, welcoming speech. Third, plenary lectures and discussion. And fourth, closing. The first agenda is the opening, which will take place as we sing Indonesia's national anthem and followed by the unity hymn. Ladies and gentlemen, please stand up. welcome. Please be seated. Now we go to the next agenda. We will listen to the opening remarks from Dr. Ulfa Elvia, Master of Health, Plastic Surgery, Aesthetic and Reconstruction Specialist, Burns and Wound Subspecialist Consultant, as the Dean of Faculty of Medicine, University of Jember. To Dr. Ulfa, please take your time.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. It is my greatest pleasure to welcome every one of you to the international webinar today. Before we proceed, I would like to express our gratitude to my university, University of Jember, and all the committee for their support and work in making this event possible. It is through their good cooperation and vision that we can gather together in this very special occasion today. Still in the middle of celebrating Faculty of Medicine 23rd anniversary, we are honored to have a lineup of experts in their field in this very special event. We have invited speakers from Indonesia, Japan, Malaysia, and Thailand. Thank you for Dr. Nur Adibah binti Mohidem from University Sains Islam Malaysia, for Dr. Al Munawir from Indonesia, and also for Assistant Professor Atira Nanda Kumar from Department of Epidemiology and Preventive Medicine from Kagoshima University Graduate School of Medical and Dental Science, and also Associate Professor Dr. Watasit Siriwong from Public Health College and of Public Health Science, Kulang Krong University, Thailand. They are here to share their vast knowledge and experience regarding our theme for today, with its Society 5.0, a new challenge and opportunity to agromedicine. Through this event, we aim to explore and deepen our insight regarding agromedicine. This topic has been our main concern for the last few years, but it is still relatively new in the medicine field and to the community. We have, through this international webinar, we can form a scientific forum to gain knowledge, share experience, and discuss all the issue regarding agromedicine worldwide. We hope all the audience can participate actively today and share your thought with all the speakers, since it will be a valuable opportunity for us. Once again, thank you for the Honorable my Rector, University of Jember, also for our Vice Dean Medical Faculty, and also the lecturer and my student. Thank you for all being here today. Please join me in giving a warm round of applause to welcome our distinguished speaker today. Thank you. Thank you.
Thank you so much, Dr. Ulfa, for the amazing speech. Next, we would like to invite the Rector of University of Jember, Dr. Insinyur Iwan Taruna, Master of Engineering, to deliver the speech and officially open this webinar. To Mr. Iwan, please take the time.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning to everyone here, distinguished participants, speakers, my dear colleagues, ladies and gentlemen. First of all, allow me to invite all of you to be grateful to Allah Subhanahu wa Ta'ala, who has given us health so that we can be here to join this event, the seminar, who bring the theme of Society 5.0, new challenge and opportunity to agromedicines. So on behalf of the University of Jember, it is a pleasure and honor to welcome you to this seminar. Yes, of course, this is organized by the Faculty of Medicine, University of Jember. I suppose this event is, the chairman to be a dean, because I don't have any notice about who is the chairman of this webinar. I got notice also that this event is held on celebrating the 23rd anniversary of the Faculty of Medicine, University of Jember. Therefore, I would say the happy anniversary, Faculty of Medicines, University of Jember. Wish you get all the best, and you will got the blessing from Allah Subhanahu wa Ta'ala to be a good and very good institution in Indonesia and also in the world. Amin. I'd like to deliver my deepest gratitude also to all participants here who are willing to come and will enjoy this seminar during I think half of day today on until afternoon. Moreover, I would like to extend also my special welcome to all invited speakers, as mentioned by the Dean, who will be presenting and discussing the topic related to the seminar theme, as I mentioned before, about Society 5.0, a new challenge and opportunity to agromedicines. It is a great honor then for us to have Dr. Nur Adibah binti Mohidem from USIM. She will bring a topic about agriculture artificial intelligence impact on health. And this is interesting topic, And more interesting, Dr. Al-Munawir, PhD, will bring a topic about the future trends in agriculture. Why interesting? Because he took my competence already, because he will talk about future trend in agriculture, as a doctor, as a doctor, I mean, in this university. And then Assistant Professor Azira Nandakumar, PhD, from Kogoshima University of Japan. She will carry out the topic about environmentally induced disease, the role of cohort data in Society 5.0. And maybe the last topic will be carried out by the Professor, Associate Professor Dr. Batasit Siriwang from Chulalongkorn University. He will talk about children risks, a new challenge and opportunity to agromedicine. To all honorable speakers, I don't know who has joined in this forum. Please accept our greeting and thanks to all of you. For your coming to this event to share your knowledge and experiences. To all participants, again, I hope you all enjoy the exciting speakers to come. Dear participants, ladies and gentlemen, the seminars aim to provide a forum for presentation and discussion. I hope the students lecture maybe later actively discuss about the topic, what will be the what the speakers will bring in this forum later on. I expect we will have deeper insight about how we should be adaptive to the Society 5.0 era, because with that, we assume that it will keep us to survive and sustain under unpredictable and never-ending world change, except at the Qiyamul Akhir. He will never-ending world change until Qiyamul Akhir. I do hope also that all scientific talk and papers, maybe there are paper later produced or distributed to the participant. It will inspire to us to be more productive in this, field, and also enable further improvement in our work. In addition, I appreciate and fully support the holding of this seminar, because, yes, as mentioned by the Dean, this is relevant to our institution vision and mission. So, accordingly, I do encourage the seminar to promote extended opportunity again in research, maybe collaboration with all the speakers who are, presenting the papers today. I think you can freely contact them, and then you make some appointment and to propose some, like research collaboration or etc. All right, let us just begin this conference by saying Bismillahirrahmanirrahim. I inaugurate officially this seminar. I wish you a very productive discussion and exchange of knowledge during this meeting. Last but not the least, I apologize should there be any inconvenience that occur, maybe before, during, or after the event. May Allah bless us with the good health so that making this event successfully and enjoyable. Thank you. Akhirul kalam. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you so much for Mr. Iwan Taruna for the great speech and officially opening these events. Ladies and gentlemen, before we continue to the main agenda of today's events, let's have some documentation. For Mr. Iwan, all the Vice Deans of Faculty of Medicine of University of Jember, and Dr. Ulfa as the Dean of Medical Faculty, Dr. Laksmi and Dr. Munawir, please join us in the front to take a documentation together. Okay, the documentation will start in 3, 2, 1. Once again, 3, 2, 1. Once more. We will take the documentation with all the participants that have joined us via Zoom meeting and all the participants in this room. Please turn your camera on and be prepared. And also to all ladies and gentlemen in this room, please stand up. The documentation will start in 3, 2, 1. Once again, 3, 2, 1. Yeah, for freestyle, please. Yeah, agromedicine. Thank you. The documentation will start in 3, 2, 1. Thank you so much. Once more, thank you so much to Mr. Iwan for joining us today. If you have another agenda, you can leave this room and pursue your next agenda. Well, ladies and gentlemen, the next agenda is the plenary lectures and discussion that will be divided into 3 sessions. For the first plenary lecture with Dr. Nur Adiba binti Mohidem. Second session with Dr. Al-Munawir, Master of Health, Doctor of Philosophy. Third session with Assistant Professor Athira Nandakumar, Doctor of Philosophy. And the fourth session with Associate Professor Dr. Watasit Siriwong, Doctor of Philosophy. This plenary lecture will be guided by Dr. Laksmi Indraswari, surgery specialist, as the moderator. Well, Dr. Laksmi is a lecturer and surgeon in anatomy laboratory at the Faculty of Medicine, University of Jember. Without any further ado, to Dr. Laksmi, time is yours.
Bismillahirrahmanirrahim. Alhamdulillah. Good morning, everybody. Good morning, dear all the audience here in this room and all the participants that already have joined in our Zoom room. And I would like to once again welcome dear all the honorable speakers in today's webinar. I'm thrilled and honored to have all of you as our speakers today in this morning seminar. As we know, the Society 5.0 is a human-centered society that balances the economic advancement with the resolutions of social problems by mastering highly integrated cyberspace and physical space. If I may say, the environment around the world is in an era of a drastic change recently. The economic growth and then life becoming more convenient, and then there's also longer lifespans of the society, and also an increased demand for energy and foodstuffs. This growth and changing also followed by a couple of problems, if I may say, social problems in specifically speaking. And perhaps by this morning today webinar seminar, we will be able to have a broader and a wider way of thinking about how this new era is going to affect us, going to have an impact of us, and at least maybe this morning we can have a little talk and share thoughts about one scope of health and agriculture. So today we're going to talk about Society 5.0, a new challenge and opportunity in agro-medicine field. For the first plenary session, I will be having Dr. Nur Adibah binti Mohidem. She is a lecturer at the Department of Primary Health Care, Faculty of Medicine and Health Sciences from Universitas Sains Islam Malaysia. All of the audience can read her curriculum vitae in our screen. And today, Dr. Nur Adibah is going to talk about agricultural artificial intelligence impact on health. This is going to be an interesting topic. So good morning, Dr. Adibah.
Good morning.
So I think you can hear my voice clearly?
Yes, I can hear clearly.
Okay, lovely to meet you today. You are going to have around 45 minutes for your topics. Are you ready?
Yes. Can I share the slide
Of
now?
course. Yeah. Okay, we can see you clearly.
Okay.
Yeah.
Assalamualaikum and a very good morning.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillah. It is, I feel, thank you for inviting me for this international webinar. And I feel honored to participate in this seminar in terms of the integration between artificial intelligence in agriculture and its impact on health. So this topic is agricultural artificial intelligence impact on health. Will cover the diverse scope in terms of agriculture, software computing, and also public health. A little bit about my background. I, Nur Adibah binti Mohidem. I currently work as lecturer at Universitas Sains Islam Malaysia under Faculty of Medicine and Health Sciences. And previous that, I have experience to work as a researcher at Universitas Putra Malaysia under Faculty of Agriculture in terms of precision agriculture and also smart farming. My PhD in environmental health from Universitas Putra Malaysia. And my research interest covers about artificial neural network, geographic information system, environmental health, and precision agriculture. This just to share with you, this is an example of publication in the field of agricultural artificial intelligence, which is one of the example is the use of drone to detect weed in agricultural field. And another example, we use mobile apps, which is IoT, Internet of Things technology, to detect pests and disease on the crops. Then another example is the application of GIS, which is geospatial mapping, one of the AI technologies to tag the durian, what is the fruit in nation fruit, which is by using images, which is aerial imagery, which is remote sensing, and the data was analyzed using vegetation indices algorithm. This is another example of the use of multispectral sensor, which is the camera attached in the drone, and also the mobile applications. This a little bit about the artificial intelligence. Artificial intelligence is now everywhere around us. It's starting from the years 1950 and continue to increase until 2008. And 2008, there is emerging evolution of these technologies. And until now, 2017 and 2023, this technology keep develop, which is to transfer how the human brain in terms of to performing several tasks in our daily life. And it covers several industries, including agriculture, health, food industry, and also tourism industry, and etc. So this artificial intelligence, it is normally applied the machines or computer programs that perform tasks that require the human intelligence, which is machine or computer program that learn and try to make a reason, solve the problem, and make a decision on how people can solve a problem on certain tasks, which is it covers wide range of components, which is consists of around 6 components, which is the biggest scope is the natural language processing and also the computing. And what normally research being done is actually the machine learning, how the machine analyze the data, which the involvement of statistics and also the computing software. And also consists of deep learning and neural network, which is consists of neurons, several neurons that being developed from day to day, which is certain as there is more expert and more publication, about 100 publication per day that involve the AI. For per year, about 3,000 publications that involve AI in their research. So AI keep emerging until now. For this topic, AI in terms of agriculture. Agriculture is the main occupation field, and due to the rising population, which is United Nations projected the population to increase up to 9.7 billion in 2050, in which put more pressure on the land. The world now has to feed about more than 50% in 2050 to feed the food to be distributed into the increasing population. Therefore, the traditional methods, which is involve the normal human labor, are not enough to handle this huge demand of increasing food productivity. So that this is the reason why farmers and also the agricultural companies need to find an alternative on how to increase the production and reduce the waste of the pesticide, herbicides, to ensure that there is an efficiency of the crop production in the field. Therefore, we found that AI is the emerging part of agriculture industry, and also rising of the technological evolutions in terms of producing more food in a more efficient way. So there is several applications of monitoring crop growth. For example, which is the use of sensor in the computer vision model to perform the human observation by identify the stages of each crop growth, which is sensor, able to distinguish between healthy and infected plants in a real-time basis, and data was classified and being analyzed using algorithm in the machine learning, so that this sensor data could vary in terms of soil moisture sensor, fertilizer sensor, and also the natural nutrient level to analyze the growth pattern over time, which means that the farmer no longer to make their trek into the field to examine the crops, which is reduce the cost, more efficient way, and also more economical for the farmers and also the industry as a whole. Which is another example is the pest and disease management. It consists of a sensor or drone that connected on board by using its electronic system that transmit the data into an internet, and the image being processed, and the farmers can simply identify the insects, which is the pest and disease could be identified, and the plant could capture the image by the camera using image recognition software, and the software could directly generate some information of the disease and what methods to control treatment. It's a summary in this picture. Okay, these AI technologies using sensor attached in the drone, which is able to identify the insects and disease in the crops, which means that the neuron will calculate and also analyze by using algorithms, for example, convolutional neural network, which is CNN, to analyze the data of the previous data to predict the unseen data. So the farmer can identify the location and also the amount of pest and disease in a real-time basis. This is an example of the drone. For example, in the greenhouse gases. Okay? So the farmer can monitor by using their apps. There is a microcontroller that able to identify where is the precise location of the pest and disease. And also in the apps, there is a suggestion how to remove the insects at the entire area. So the drone will capture the image and analyze using image recognition software in the fields. Another example, which is the application of the pest and disease also, based on the image, so the farmer will receive reports based on the image that they captures on their smartphone by using IoT technologies. For example, it helps the farmer to grow better condition of the crop, to differentiate between healthy and infected disease, which is, for example, the cassava crops can be monitored using the apps. Nowadays, there are several types of apps that differentiate based on the purpose of the application. Then the machine learning being analyzed in the neural network attached in the apps. For example, the farmers can identify what is the type of the disease of the crops, which is AI can cover a wide range of technologies. Another example is the precision weed control, which is the farmer can spread the herbicide on the targeted areas more efficient, which is previously by using the manual methods. The farmer simply spread the herbicide throughout the entire area without knowing there is requirement to spread the herbicide on that particular area. by the precision weed control, the farmers can spray the herbicide or pesticide only at the infected area, which can reduce the time and cost and also more economical, which is one of the example of the drone application to capture the weed image. For example, when I work as a researcher at the Faculty of Medicine, all right, the drone will capture the image of the weed in the field. It consists of hyperspectral, multispectral, and RGB sensor. So the camera attached in the drone to capture the presence of weed, and the camera will process the image by using remote sensing software. For example, the drone will fly, and the lowest level of altitude is more better because the farmer will get highest resolution of the image. Another application of the AI in agriculture, which is the precision weeding process using robots, which is automated weeding with the help of sensor that attached in the robot could help to remove the weed more efficiently, which is the robot will guided along the row to remove weed and able to distinguish between crops and also the weed plants by using the vision-based technology, which includes laser, which is thermal energy, that to capture and differentiate between which one is the crop and which one is the weed. Because the farmer need to remove the weed because weed will inhibit the growth of the plant. The weed will compete with the plant for the absorption of light, sunlight, nutrient, soil moisture content, and also water requirement. So by removing the weed, this can improve the crop growth of the respective crops. For example, this is the intelligent weeding system, which is, as you can see here, the robot will capture and differentiate between weed and crop. And the robot will simply identify the weed and remove by using their tools attached on the robot, which is then being analyzed using machine learning techniques. For example, this is to assess the plant health and identify the density of the weed. For the left side, we can find what is differentiate between the weed and also the crops. Therefore, this robot able to identify the weeds by using their automatic weeding, and also the farmer can monitor the location of the robot by the GPS attached on the robot and monitor their localized location using Google Maps. So this is how automatic robot being used in the agriculture. Another example is reduce herbicide use. The use of herbicides, which is use computer vision to monitor and precisely spray the herbicides on the weed. For example, this robot not only can able to remove the weed at the respective area, they able to spray the herbicide at the targeted area, which is the weed. By the manual labor, the farmer simply spray the herbicide throughout the area. By using this robot, they can just spray the herbicide only at the targeted areas, which is the location of weed, without hurting or damage any of the crops. Because the certain algorithm in the neural network attached in the sensor able to identify and visualize where is the location of the weed and also the crops. This being used in several countries. For example, Japan, which use technologies in terms of robots. Then people can, also the farmer can monitor the robot through their apps, or also can be automatically being operated without human labor. This is example. So the farmers can spray the herbicide row by row, which is the weeding process in the field. So there's able to leverage of the image to spot the difference between plants and weed. Also, the camera can be managed by using the apps to set certain algorithm for the targeted areas. This example by the US tractor. For example, pesticide in seed industry this application could reduce the cost more of per year and per month for the agriculture industry. So that based on this those technologies, AI application in agriculture could incorporate multiple data types in the farm. For example, it can remove the animals' potential in the field that could destroy the crops at the remote farm locations, and able to track all the data by point, by location, even at the remote areas. And also the farmers can monitor in a real time by using IoT technology, which is involvement of Internet of Things. And also for the farmers able to predict what types of food, when they will harvest, which is which more efficient and reduce the cost, and also the time that need the farmer to be at the field. So this is example of research in Japan. The farmers use neural network to sort cucumbers by using the image, and also by using the statistical and also the mathematical modeling, which is there are several types of cucumber. By capture using the hyperspectral camera, it can differentiate what is the different types of cucumber. Another example is the smart automation of irrigation. Just to share experience, when I work as researcher at University of Malaysia previously in the field of smart agriculture, I and a team developed a fertigation system, which is fertigation that is very sensor attached at the root zone of the crops, in which it can monitor at which time that nutrient could be released to the crops, and which time the water that could be delivered into the crops, which means that all those nutrient and water requirement being operated by the sensor, and also have timing. What is then the user able to monitor the time and also the amount of nutrients, amount of soil moisture, and also can forecast the weather by using the apps, by using the internet. And it also being connected by the microcontroller, and also the sensor being attached in the using pump, which is the water will flow through the pump and being distributed into the entire crops and until the root zone of the plants, in which it's involved several types of sensor: soil moisture sensor, humidity sensor, temperature sensor, that integrate into machine learning, which is a branch of AI technology for the irrigation system. So this technology could increase the production of agriculture without involve of large amount of manpower, which is they can measure the level of water needed, what is the current temperature at the fertigation system, and also the humidity, nutrient, and also can forecast the labor. when my experience, the type of plant is by using the tomato cherry. So the tomato cherry and the researcher or the postgraduate student able to monitor the growth of the tomato cherry starting from the seedling until it's become harvest and until the harvesting time. And they develop software that monitor the amount of water and nutrients by using IoT technologies. This is the another application, which is soil moisture and also the sensor. Example, soil moisture sensor and drop. For example, this is how the fertigation system being operated, which is there is a pump located which to flow the nutrients and also water into the targeted area, and the system being controlled by the microcontroller. This is how the water being flow into the crops and being operated by the sensor, which is consists of herbicide also. It is designed for different types of unique crops, which is different types we label. And when you want to differentiate what's the difference of the growth for each crops, which is the sensor will send to the farmer and they will inform about the moisture. And the farmer can turn off the water supply if any problem occurs at the right time when the harvesting. So as an overall, okay, in terms of labor, this AI in agriculture could improve the labor scarcity in the field, which is the labor shortage has led to huge revenue loss in the crops. As alternative, by using AI technology, by using the robot as a platform, which is capable to process, sensing and perform the function at a higher volume and a faster rate as compared to human beings. If you can see in this video where the robot can capture the grape by analyzing the neuron and also machine learning technologies to identify which one is the crop that they want to take for the harvesting and taken to the grocery, which is able to reduce the human labor. Another example is the machine learning technologies and also robotics can perform another task, which is can differentiate which crop that they need to pick and select during harvesting, which is, if you can see here, the robot only collect the red color of the tomato cherry, for example. So there is mathematical algorithm in the sensor, which the robot being designed, and the robot and learn by the machine to differentiate which one is the food that be ready for harvesting, which is this robot able to perform days and night, which is different between the people requirement. And as you can see here, okay, the robot picked the strawberries, for example, just to show we also we can get the clear figures on how AI being used in agriculture and in the farming industry. So this is the overall technologies for the precision agriculture, which is the name of precision, which means that the technology being used at the right time in efficient way and a more productive approach. For example, automatic steering system, which is without the involvement of people, which is automatically being conducted, and geomapping, For example, the drone that, as you can see before, capture the image of the crops and identify the weed, insect, or pest. And from the identification of weed, insect, and pest, this image will be analyzed using geomapping, which is in terms of map, by using the GIS software, which is another branch of AI that purposely for mapping a substance. It can be used also in medicine, for example, mapping of tuberculosis or mapping of any healthcare services, mapping of disease. For example, during my PhD, I do hotspot analysis by mapping the tuberculosis cases, TB cases, and I predict the TB cases in the future by using the neural network. Another example is sensor and remote sensing, which consists of a wide range of technologies, which is the satellite, and also remote sensing, which consists of hyperspectral, multispectral cameras attached on the drone. Another example is the integrated electronic communication, which involves the electrical system. For example, the irrigation, it involves the electrical technologies, which is how the microcontroller being connected into the sensor. Another example is variable rate technology, which is those technologies was being carried out in a high rate, and then farmer can monitor the rate by using their apps. And the last one is high precision positioning system, which is the farmer can localize the location of the drone or the robot by using the GPS in the, for example, in the handphone or in the iPad or other devices. This is an example of wide range of precision agriculture. It also can be used in terms of health and medicine also, based on the certain amount of disease, location of the disease, how the, for example, COVID-19 being spread across the entire area. This is the flow, short example, flow, which is the step in precision agriculture. For example, based on sense, which is a sensor that able to capture the data and upload into the monitoring system, which is the platform is, for example, drone, satellite, remote sensing, GIS, and also GPS. Based on this data, which is sense data, the data was analyzed by mathematical or statistical analysis, and the data was analyzed by using ANN, deep learning, computer vision, etc., which is the data is presented to the farmer for them to make a decision. And the next is for prediction, was based on the sense, analyze the data, and the farmer can make prediction, which is when is the ideal growth condition and what is the disease being used to analyze the data. For example, it is give a good advice to the farmer for the seed planting, when to spray the herbicide, when to apply the fertilizer at the targeted area and not throughout the area of the crops. When is the time for plant to harvest, which is another example is another environmental condition, which is weather forecast, and also being applied for irrigation, which is to optimize the water requirement into the plant. After capture the data, analyze and make prediction, these steps, now the farmer can act. Then the farmer can get notified and take the action directly from the application. So based on those technologies, AI in agriculture, there is impact on health, which is the positive impact. How the application of AI in agriculture could solve certain health problems. By introducing AI in crop management, the agriculture industry, food industry, and also Ministry of Health can tackle many health problems, mainly occupational health related disease, and improve the quality and also the quantity of food production. For example, the fungal infestation in the crops. For example, there is pests and disease in the crops. And one of the example of fungus is Fusarium head blight, which is produce mycotoxins. This mycotoxin, when being when contaminated, could contaminate the food products, which is cause several health problems, including vomiting and affect the gastrointestinal problems for human. So, as a solution to prevent the presence of pests or fungus in the crops, in the plants, so AI be an alternative to reduce the fungus in the crops, to reduce the pests in the crops, which is imaging technique and also machine learning algorithm being used to analyze the image and identify the presence of fungus. For example, the data being captured and trained in the model, which is based on the machine learning models, the researcher or the farmers train the data based on the previous data and able to run the neural network and analyze the data and validate to see the unseen data to solve some problems that involve the pest and disease, which is involve, for example, the deep learning, which is involve the mathematical model of neuron in the machine learning, and the farmer can make the prediction when to spray the pesticide or herbicide at the targeted areas. Which is another example is the herbicide and herbicide usage to control weed in the crop. For example, overuse of herbicide could have negative impact on our health. For example, for the acute health effect, could skin rashes, blindness, nausea, also diarrhea, and for the chronic effects could cause cancer, harm to the reproductive system, neurological and development toxicity, and asthma. But those effects depends on the toxicity of the herbicide and also the pesticide. So based on this is problem mainly occur for the farmers because they being exposed to those hazards, which is the occupational medicine or occupational hazards in the field. So to prevent this occupational health impact in the field, AI technology being used, which is, for example, we use site-specific weed management, remote sensing, which is able to capture the weed in the crops, drone, etc. So this pesticide or herbicide only being applied to the area where they are needed. That reduce the amount of herbicide, which is results to reduce the risk of contamination. Another application, yeah?
You only have around 5 minutes.
Okay, thank you.
Thank you.
So another advantage of this AI in agriculture in terms of health, it can improve the safety and quality of food products, which is agriculture products, to prevent the presence of harmful microbes or other potential safety hazards. As an alternative, AI being used to identify more rapid identification of food safety hazards, which is for the overall, it can prevent the widespread illness or disease, which is prevent the contaminated food reach to the consumer. This is the overall impact and of the role of AI and its impact on health. I just explained on the impact of overall AI technologies in terms of food processing operations, food safety, and also the nutrition recommendation, which is reduce the prevent and also reduce the foodborne disease, improve the quality of food products and reduce waste, and help to find and also solve nutrition problems. There is several advantage. There is several advantage, also challenges of adopting AI in agriculture. One of the challenges to it is AI increase the inequality or reduce job in rural areas. It is high cost that involve hardware, software, and also the training for the future researcher and also the farmer, especially at the remote areas. Another challenge is difficult and time consuming to solve certain problems that robot cannot solve the problem, because robots can only solve the problem that involve the large amount of data and also the solid data, because the robot will calculate the neurons by using the machine learning algorithm. And the last one is on the privacy concern and ethical concern, because the data being spread by using the cloud. So it's enhanced to confidential issues about the data. So as a conclusion, AI being used to improve the productivity, efficiency, and also sustainability in terms of agriculture, food, and also health industry. It is cover a wide range of applications, which is farming, pest management, food processing, quality control, and supply chain management of agriculture food production. However, we must ensure that there is sufficient talent to apply AI in sustainable manner, which is require high cost to invest in education and train the researchers. And the last one, in terms of health, application of AI could minimize health impact, mainly due to the presence of pesticide and also herbicides in the farm, mainly among farmers. Thank you.
Wow, thank you, Dr. Adiba. Thank you so much.
Thank
Maybe
you.
we can have an applause for great information. I learned a lot this morning, Dr. Adiba. Can you still hear my voice clearly?
Can.
Oh, okay. Can I have the viewer of me and Dr. Adiba side by side, maybe? Is there any questions from the audience in the auditorium? Or maybe in the Zoom room? Is there any questions in the Zoom room? I am not joining the Zoom room, so... Is there any questions? No questions? Dr. Adiba? Dr. Adiba?
Yes.
Yeah, you were talking that you were focusing on smart farming, is it correct?
Yes.
How many % is already being implemented in Malaysia for this smart farming stuff?
Now, smart farming keep increasing, and evolution of this technology starting mainly from 2015. And percent is about 50% being implemented in our agricultural system.
Starts from 2015 already?
Being evolved.
Wow.
By using the sensor, mainly the IoT or apps, the small scale of the technologies.
Okay, so it's now already reaching 50% of almost all fields of agriculture?
Yes, mainly involve the drone and also the multispectral cameras, but the robot are not yet implemented throughout.
Okay, and so about the weed control and herbicide, for the past 8 years, it's already being implemented, right? So how is it the impact on the Malaysian farmers' health in generally? Do you already see a decline of health problems or something like that, Doctor?
In terms of the decline of a health problem, not really significant now, and also quite less research on that particular topic, but it could increase the overall crop productions. In terms of health, I think maybe need more research on the AI impact in agriculture for health.
Maybe it's because of the research topic doesn't really focus on that part, but rather to the productions of the agriculture.
Yes.
Okay, got it. So, is there any questions, dear Dr. Septa? We have questions from the audience in this auditorium, Doctor.
Yes.
Thank you, Dr. Laksmi. Also, thank you to Dr. Adiba. I want to ask you about, it's any calculating about the value between traditional farming and smart farming, like your present today. And also I want to know about calculating of impact in the health. Maybe any journal or another like intoxication or another impact of agro technology. It's maybe decrease or still not data. Thank you, Dr. Adiba and Dr. Laksmi.
Thank you for the question. It is a good question. For the first questions, which is there is failure between smart farming and also the manual technologies. There is certain failures, which is some of the technologies cannot be solved, and the problem cannot be solved by the sensor, because the sensor normally require large amount of data, and the sensor was being calculated by using the mathematical algorithm or neural network. So if there is uncertainty problems in the field, it cannot be solved by the robot, but it can be solved by the human advice in the field. So for overall, the integration between smart farming and also the human labor must align, because the farmer need to monitor the efficiency of the crops in the field. Not all the problem can be solved by the robots, which is need to and advice for in terms of any uncertainty problems in the field. For example, when I work as researcher at the Faculty of Agriculture, UPM, so the tomato cherry, there's some plants could not be planted or not harvesting at the right time. This is because there is certain leakage of the nutrients in the pipe. So there's problem in the sensor. So when the farmers conduct the fertigation system, for example, when they spray the nutrient into the targeted crops, for example, tomato cherry, they must set more crops as a backup in case there is problem in the sensor. For the next questions on the impact, which is the direct impact of the smart farming technologies on health. Actually, I also searched previously on the certain research, but there is, on my current knowledge, there is no published data that exactly modeling or identify how the AI technology in agriculture could reduce the health impact. But the agricultural technology, by using AI, artificial intelligence, could reduce the health impact specifically based on the less use of pesticide and also herbicides, but not directly based on the AI technology, but based on specific herbicides or pesticide. Thank you. I hope I answer your question.
Okay.
Thank you.
Thank you, Dr. Adiba. Dr. Septa, it's already answered, right? Okay. Dr. Septa already accepted the answer, and it's a great new information for us. Is there any other questions from dear colleagues or other participants? Yeah. We have one more question. Dr. Adiba, is it okay with you?
Okay.
Test. Yeah. I hope I am audible. So I'm interested in the topic, and I want to know more about the cost of this management. So I believe that this whole process will have a high price to cost the management and the maintenance of the device and the training process for the farmer. But I want to know in which point do you, at least how the progression of this farming condition can be made to be capital return, or what as breakpoint of the cost from the break cost for it to become profitable for the farmer. In which condition the farmer will have to wait a few time. And in this condition, what aspect does the farmer have in the social economic condition for the farmer? I think that's all from me. Thank you.
Thank you. Do you get it, Dr. Adiba? Do you get the question?
Yes.
Okay.
Thank you for the question about the cost. Yes, it is a challenge by using the AI technologies because it's enhance higher costs in terms of the software, hardware, and also to how to train the farmer, especially at the remote areas, which is the government or the respective bodies must invest a large amount of cost and also the investment to train those farmers, especially at the remote areas. May I know this about the second question?
About the maintenance?
The maintenance, okay. So the maintenance mainly being connected by the software engineer at the site. Mainly some of, for example, if the technologies less amount of people that being trained, normally we have certain companies or bodies that specialize on the particular software or sensor. But then these companies will get MOU or collaborate with the agriculture industry, for example, can give some information to the farmers, which is mainly the farmers can be trained, which is by the help of the government and also the respective bodies relates to the certain technologies in AI.
Okay, so it's really relating to a lot of aspects and subjects. Is already answered the questions, sir? Okay, thank you. I have one more question. Have you already got a data about like what kind of, economically speaking, what kind of farmer that's gonna take the most advantage of this stuff? Like maybe the scale of the farming. Is it can we use this kind of stuff even in a small farming area, or it has to be middle up range farmer scale? Thank you.
Thank you. Mainly it's depend on the purpose of the applications. Mainly it's require large amount of areas because it involves certain, for example, the drone need to capture the image at the certain altitude to capture certain, for example, weed, pest, and disease at their respective areas. For the research, they can be also being connected in the greenhouse areas, which is normally researchers for the postgraduate student, they use the compare both in the field and also in the inside location, which is at the greenhouse gases classes.
Then the data is used for a bigger scale of area. Okay, thank you, Dr. Adiba. No more questions in the Zoom room, in the auditorium? Oh, I guess maybe we have more questions, but we have limited time. So if it's okay, maybe one day we're gonna give you an email if we have some problems or thoughts to share with. For the committee, would you please share the certificate that we're gonna give to Dr. Adiba? For the committee? Oh, we're going to give you a certificate of gratitude. Okay, Dr. Nur Adiba Mohidem, we really grateful to have you this morning. This certificate is presented to you as the speaker for this international webinar, Society 5.0, New Challenge and Opportunity to Agromedicine. Give a big round of applause for Dr. Adiba. Have a nice day, Doc. Hope to see you around. Assalamualaikum warahmatullahi wabarakatuh.
Thank you. It is pleasure for sharing knowledge and experience in this international webinar.
We will
thank you.
So bye. See you soon, Doc.
Okay, see you.
Okay. Now we're going to move on to our second plenary lecture. It's going to be offline. Our dearest speaker is already here with us today. Can I have the curriculum vitae of the second speaker, please? For the committee. Our second speaker is Dr. Al-Munawir, PhD. He is one of the lecturer in pathology anatomy. He's focusing his research on toxicology and also really having a lot of work regarding stuffs in agromedicine. if I may please share the curriculum vitae of Dr. Al-Munawir, PhD. And this morning, he will present us a topic about the future trends in agriculture. Dr. Munawir, if I may have you to sit next to me. Can I please have the PowerPoint slide to be shared by the committee? Good morning, doctor. How are you?
Good morning. Good morning.
You're fine?
I'm fine.
Alhamdulillah. Okay, today you're going to talk about the future trends in agriculture. Moving forward to the PowerPoint slide, please. You have around 40 minutes to do the presentation?
Maybe 5 minutes.
Maybe 5 minutes. 5 minutes will be okay as long as it's a grade one. And then we're going to continue with the discussions. Okay. You may start the presentation, doctor.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, audience. My student here. I think it is clear from Professor Adiba about agriculture. Smart agriculture. Smart agriculture is maybe not similar between a country. Between country with another country, it is different. Depends on many conditions. Okay, slide. Revolution in agriculture is go to better and better. Smart agriculture, also known as precision agriculture, is a revolutionary approach that leverages technology and data to optimize farming practice. This innovative concept aims to address various challenges faced by traditional agriculture, such as increasing productivity, conservation resource, reducing environmental impact, and improving overall efficiency. Efficiency is sometimes easy, but sometimes it's difficult. As in Indonesia, it's different with the USA. Okay, next slide. Oh yeah. Yeah. In this schema, we know society is developed. Society 1.0 is hunting. Because nature is more and more than people, and then because people is more and more people to get food should planting. That's society 2.0. The agriculture is develop to society 3.0 because industrialization, industry, we use more machine. And that time, long years ago, this is modern agriculture, but now no, because the society is developed again to 4.0 information, all using internet. This is open. We can communicate with people in the long another country, but still have change about analysis, no analysis. Jadi and then become developed to society 5.0. In this society, there are we have big data, and we have artificial intelligence, and then we can easy to have information, read the information, and this is can we use to smart agriculture. This challenges in traditional agriculture. In smart agriculture, relates integration, advanced technology, and including the Internet of Things, sensor, drones, artificial intelligence, and data analysis. Internet thing device and sensor got real-time data on soil moisture, temperature, humidity, and crop herds, provides farmer with accurate and time information. Drone equipped with a camera and sensor can monitor larger area farming, detect crop disease, pest, and nutrient deficiency, and enable targeted intervention. Smart agriculture using data-driven decision making. Smart agriculture using precision farming practice. Smart agriculture enhance crop monitoring and management. Smart agriculture sustainability and environmental impact. How about economy benefit? The problem in smart agriculture is cost. In initial cost, because they need more equipment, technology, and accelerator. And then not all farmer skill, and the problem and another problem is labor, because in smart agriculture they use less people. I think it's have a problem in social. This is in Indonesia. In Indonesia, we have experience. They improving tool to using artificial intelligence with sensor like this using Android. I want to show you all video in the about artificial about smart agriculture in Netherlands. Please operator to show our video. In this video, smart agriculture use less soil, use effective material like water, like pesticide, or they not use pesticide.
According to the World Resources Report, in order to feed 10 billion people by 2050 with the same level of food production, most of the world's forests must be deforested. Another way out, experts say, is the urgent creation of a more efficient agricultural system that will help solve the impending problem of world hunger. The Netherlands, a small country that has been able to rank second in the world in terms of agricultural food export, is a worthy example to follow. But how exactly did they manage to achieve this result? The simplest way to increase yields is to increase the use of various soil fertilizers and pest control chemicals. Although this helps to increase yields in the short term, however, such methods require a constant increase in the dosage volume, which leads to soil degradation and its inability to grow anything except for a few crops, and then to desertification. Due to various weather conditions and terrain features, the degree of soil degradation can either accelerate or slow down, but the result will still be the same. Another major problem is soil compaction. In good condition, the soil should consist of 50% of the earth, 30% of water, and 20% of air. But the constant driving around of tractors, trucks, combines, and other agricultural machines upset this balance. As a result, the soil layer 1 meter deep becomes dense and is not capable of producing a good harvest. It is for this reason that 48% of all seedlings never germinate. Thus, without serious innovative technologies, complete soil degradation is just a matter of time. It is therefore extremely important to take into account the best agricultural practices of a country such as the Netherlands. Scientists unanimously declare that today it is necessary to allocate sufficiently small resources in the short term in order to then receive huge profits in the future. And this is not to mention the prevention of mass hunger and deforestation. So, how did the Netherlands manage to develop their agriculture? It all started almost 50 years ago when the government set a course to support the development of agriculture. Before this, the industry was owned by farmers and usually had little control from the government. Some historians believe that the reason for the change was visionary politicians who saw huge prospects in the sector. Others believe that it happened historically because Dutch tulips and cheese have long been known all over the world. Some also believe that after the Cuban Missile Crisis, when the world was on the brink of a nuclear war, the government decided to increase its food supplies. In any case, at that time, the state began to actively help farmers develop their farms. They created a more flexible tax policy. provided guarantees for obtaining loans, etc. The first cooperatives began to appear, united farms that could have expensive equipment in common use. In the late 1990s, even the slogan, "twice as much food using half as many resources," appeared, and what followed was farmers beginning to reduce their use of water and fertilizers. The lack of land, and the country has very little of its territory, began to compensate for the development of innovative technologies. And one example of this is the Divestine Tomatoes, a 70-year-old company. Since 2011, the company has introduced technologies for the use of geothermal energy and hydroponics. The first technology helps provide special greenhouses with warmth, creating an isolated environment in which tomatoes can grow all year round. The hydroponic system provides plants with useful trace elements and water using special banks, and saving up to 90% of water compared to traditional cultivation. The use of these technologies has led to amazing results, says Ad Van Adrichem, General Manager for Divestine Tomatoes. Our greenhouses cover an area of 14 hectares, and we produce around 100 million tomatoes a year. Another interesting example is the work of the farmer Jacob van der Born. He specializes in growing potatoes near the Belgian border. While the average potato yield per hectare in Europe is about 9 tons, his personal field yields over 20 tons. Such a high level of productivity is provided by precision farming technology. He purchased 2 specialized drones, a quadcopter and an unmanned tractor. The first drone monitors the chemical composition of the soil using special sensors. This allows to spot problems with the water or micronutrient deficiencies. The second drone, an unmanned tractor, carries out all the necessary agricultural work according to a pre-planned program. This saves not only on manual labor, but also sending the tractor to work even at night. Simultaneously, as the farmer himself admits, the lack of water is not the biggest issue. Soil depletion is much more difficult, but even this can be solved with the help of science. The absence of nutrients can be offset by cultivating plants that act in symbiosis with certain bacteria to produce their own fertilizer. Such developments were made possible by the activities of Wageningen University and Research, WUR, located near Amsterdam. The Science Center brings together scientists and researchers from all over the world, challenging them to solve the problems of creating environmentally friendly and cheap food. There is the Food Valley Cluster at the university. The name not only parodies the American Silicon Valley, but also copies its methods. It unites the scientific community with the business community. The cluster includes startups that promote innovative technologies and experimental farms and agriculture. If an idea becomes viable and commercially profitable, then it won't be long before it has many investors who are ready to continue helping the company develop. Thanks to this research center, Dutch farmers have gradually phased out the use of pesticides since the early 2000s. Scientists were able to clearly show that in the long term they will cause much more damage. Pesticides not only kill insects but also harm the soil, destroying the entire ecosystem of the fertile layer. The massive use of chemicals creates deserts which then quickly spread, capturing more and more new territories. In order not to create a problem that will destroy the farming received from their grandfathers, farmers began to independently abandon the use of chemical fertilizers and opting for natural methods instead. Thanks to new developments in the cluster since 2009, farmers who supply meat and poultry to stores have been able to reduce their use of antibiotics by 60%. This has led to better quality meat and at the same time has reduced the costs of manufacturers for the purchase of medicines. Soon, it is planned to completely abandon antibiotics. Smart flying drones capable of carrying out all types of agricultural work with minimal impact on the soil are also being developed with might and main. According to researchers at WUR, the development of this generation of drones will allow to solve the problem of soil compaction. This can increase yields with fewer seeds planted. New technologies were able to raise the level of agriculture in the Netherlands to an unattainable level. Each farmer produces on average 2 times more products than any other in Europe. The country ranks first in the production and sale of meat and poultry in the entire European Union, and the total amount of food exports exceeds $111 billion. As noted by Ernst van den Ende, Managing Director of WUR's Plant Sciences Group, today humanity faces a difficult task: On the planet, we have to grow more food in the next 4 decades than all farmers in history have harvested over the past 8,000 years. If this is not done, then more than 1 billion people will be on the verge of extinction, and about the same number on the verge of starvation. Will humanity be able to cope with this? The example of the Netherlands convincingly shows that this task can be solved. You just have to use a competent approach. But will farmers all over the world be eager to learn new technologies and use them on the farms?
I think, thank you.
Okay, thank you, Dr. Munawir. This session complementing the first sessions, right? And then we try to adjust it with what Indonesia conditions have. So, technically speaking, do you think we have to go to Dutch and do some benchmarking there, learning something, or
no.
What is it? What's on your mind? What is your suggestions? Technically speaking, what is the first thing that we should do to be able to
In Indonesia?
Yeah, to be able to do this smart farming, to make it feasible.
Yeah. I think in Netherlands is small country. That's why they improving technology
Easier to be done.
vertical farming. I think we have vertical farming, but small scale.
Oh, where is it?
Hydroponic.
Oh, hydroponic. Yeah.
Hydroponic. I think like similar. This I think is in small country. I think it's difficult to improve because we need initial cost. We need money to make like factory in Netherlands, and I think now we not need because we have more land in here. I don't know in the next 10 years, maybe. I think this is similar with another small country. I'm sorry.
Yeah. Try to get a questions while Dr. Munawir is resting for a while. Yeah. And after the second discussions that we have, I see one of the big problem that we don't have is the big data. Everything is possible to be done. The AI, the robot, the drones and everything is applicable because they have the data. And for me, I think Indonesian people, especially farmer, doesn't have enough time to collect data, or even the researcher. They might not focus yet on collecting the data. Do you agree with me? Do you think that should be the first thing that we have to do?
Yeah, I think big data, no problem, because today is open. But I think government need like collaboration with another institution like that, industry, and like data export, import from another country. And I think this problem in Indonesian farmer, because after the harvesting, farmer is confusing. What next? Who can, who will buy our product? Because it's nothing. Data is nothing.
There's no data supporting.
Yeah. That's why.
Okay. So we need data, we need support from a lot of parts,
Yeah.
and then it's time to start educate the farmer that
Yeah.
there are easier and better way to help their works. Something like that. Okay. Now, dear colleges and the audience, is there any questions from the auditoriums or the Zoom room? No questions? No questions?
Pakai bahasa Indonesia juga boleh.
Yeah. If Dr. Munawir said you may use Indonesian if there's any questions. I think they already got the point,
Okay.
sir, because we already see how improved the video that you've shared to us, and it's like our new goal. Hopefully we can go there.
Maybe.
Yeah, to reduce health problem, to reduce farmers' workload, and to increase food supply.
Yeah.
Yeah, okay. No questions? Ladies and gentlemen, dear colleges? Okay. So thank you so much, Doctor, for
Thank you.
having us here together. And because you're here with us, I would like to give the certificate. Our Vice Dean, our first Vice Dean, Dr. Rani, would be gladly to present the certificate to you. Dr. Rani, please. Thank you so much, Doctor. Do you need any help? Thank you so much, Doctor. Hope you have a good day. And ladies and gentlemen, we still have 2 more plenary sessions to go. Hope you're still focusing because we still have a lot of great topics to be shared with. And for our third theme, we're going to have Assistant Professor Atira Nandakumar. Dr. Atira, are you here with us already?
Hello, Dr. Lakshmi. Can you hear me?
Yes, I can hear
Hello,
you.
good morning. How are you?
Good morning. I'm good, thank you. How are you?
I'm super excited.
Very good. It's great. There you go.
Yeah,
Okay.
thank you so much. Good
Yeah, you're
morning,
welcome.
everyone in Jember University.
Morning.
Thank you so much.
Show a bit of your curriculum vitae for a while?
Oh, okay, go ahead. Yeah.
The comedy, can I please ask help for the curriculum vitae? Assistant Professor Atira Nandakumar, PhD, recently worked in Department of Epidemiology and Preventive Medicine in Kagoshima University Graduate School of Medicine and Dental Sciences. Today, she is going to talk about environmentally induced diseases, the role of cohort data in society 5.0. As we can see on her curriculum vitae, shared on the screen, she got a lot of work experience and then publications in health field. Scroll down a bit faster. Thank you. So, how can I call you?
You can call me Atira.
Atira. Okay, Atira.
Yeah.
You have around 40 minutes to start.
Oh, okay. Thank you. Thank you so much. And first of all, thank you for the nice words. And before moving into my lecture, I would like to congratulate Jember University on the 23rd anniversary. I hope through our MOU, our relationship between Kagoshima University and Jember University becomes stronger day by day. And my friend Dr. Anja, hello Anja, and the entire team there, thank you for inviting me to be a part of your milestone. When Anja said about Society 5 is the topic, I was not sure what I can talk. And agromedicine, again, agriculture, I have no connection with agriculture. So I was a little bit worried what I can talk. And then I thought about the part of data science. Maybe I have been working more than a decade with the cohort data. So I thought maybe why don't I put out how did we create a large data set and what are the challenges we faced and how it came out to be a good data set and that kind of work. So I will move on to my talk. Before that, if you have any question, please feel free to talk to me or ask me any question. Even you can mail me later. And again, thank you for having me. Let me share my screen. So I hope you can see my slide. So I'll be talking about the environmentally induced diseases. In general, I don't want to talk all the environmentally induced diseases, but the work which I have been doing, I will try to, that is related to radiation. So the role of a cohort data in Society 5. So in my talk, I will little talk about the background, location of the study, outline, the radiation-induced cancers, lifestyle-related cancers, and the diseases other than cancer, which is caused by radiation, the advantages of our study and limitations, and then the United Nations Scientific Committee of Radiation report, which our data got accepted. So as we know, the Earth, the planet we live, it's a source of terrestrial radiation. In general, there is uranium, thorium, and radium. So these are the three main radioactive materials which exist in soil and rock. So when the uranium and radium, when they undergo radioactive decay, it produces a gas, a radioactive gas called radon. So it is a colorless and odorless gas. So that means the soil we live, the rock around us, or the air we breathe may have radioactive materials. So that is called terrestrial radiation. So the studies on the health effect of population living in areas with high levels of background radiation for understanding the biological impact for exposure to low dose of ionizing radiation is very important. So this is the world map. I'm sorry, I couldn't find the data for Indonesia, but I will maybe by my name, you might have guessed I'm from India. So I will talk a little bit about the Indian data. So the national average, the terrestrial radiation average is 0.48. But in some places, one place of India called Kerala, the radiation is quite high. That shows that all over the world, the radiation is different. Even in one country, the radiation can be different it can be sometimes as high as 3.8 or as low as 0.48. So it is important to study what happens in these regions. So as you see here, the biggest bar, this is Ramsar, Iran, and Gurapari, Brazil. They are the highest natural radioactive zones in the world. But luckily, there is not so many people who live here, so we don't need to worry so much about that. But in Yangjiang, China, and Kerala, India, especially in Kerala, India, which is my hometown, we have a high number of people living in there, so around 400,000 people. That's quite a lot who are exposed every day to radiation. So a bit about the origin of the study. In 1959, the WHO's expert committee of radiation put out a report saying that there is an effect of radiation on human heredity. And they said that probably the people who live in Kerala, they may be exposed to around 60,000 people. According to their report, 60,000 people living in this area may be exposed to a lot of radiation, terrestrial radiation, and they have been exposed for generations. So this is just a suggestion. So they asked the India government to study what happens in this region. That happened in 1959. So this is India. In the southwestern coastal region of the India lies the state called Kerala. So this is here. and this is the bigger version of this. Even in this place, the
Atira.
other parts.
Atira, we are losing you. Can you speak a little bit louder?
Okay. Can you hear me now?
Yep, better.
Okay. So my mic just drops down. Maybe that's why. Okay. So so this is Kerala, and this small black portion of this Kerala. So this is the bigger version. This is where the radiation is quite high. This is because the water, the sea water, tend to get a lot of sand, which has which emits radiation and deposit in this region. It is because of the location. Okay, so the India government asked our parent institute, the Regional Cancer Center, it's a hospital, like a tertiary care hospital, to take care of the cancer. So, and asked them to open a special purpose radiation cohort in this area because they thought that radiation can cause cancer. So that's how from WHO it reached to India government, and India government reached to Kerala state government, and the state government asked us to start a new radiation cohort here, and that's called Karanagapalli radiation cohort. And as I said before, the number of people who live in this area is quite high, around 400,000 people. And this study area in total is 192 square kilometers with a population density of 2,000 per square kilometer. That's quite a lot. So what is HNBRA, or high natural background radiation? So that's the area where the total cosmic radiation and natural radioactivity in soil, indoor, outdoor air, water, and food lead to chronic external and internal exposure to the public. So this is after our studies, our like years of studies, we have found out that in the coastal belt region, the red part is the high radiation area. That is the HNBRA area. And then this is the middle or intermediate area, and this is the low. So we need, for our studies, we also wanted to have control area. That's the reason we pick up HNBRA area, and in addition to that low and intermediate area, because this is one full administrative unit according to the Kerala state. So you can see the sand here in these pictures. It looks so dirty, right? Actually, it is not dirty. It is quite expensive because it has a lot of monocyte, and this monocyte, like 30% of the sand in this region is black, and that is because it has a lot of monocyte. And India government has a mining industry in this area, and they keep mining this sand every few years. So that's why people in this region, they can't make a bigger houses, you know. So they make houses usually with the leaves of this coconut tree, so that whenever the government says move out, you want to do mining, they can easily demolish these houses and give to the government. And these people tend to get money also from the government because they are demolishing their houses. And then after the mining finish, they can come back and settle in their own spaces. So this is kind of a win-win for the people. So they don't want to move out of this region. But luckily, when we studied, we were thinking what radiation can cause to them. And okay, I will talk about the results later. And then according to the United Nations Scientific Committee of Radiation Research, the annual effective dose is 20 to 50 megasieverts in this region. Whereas in normal, other parts of Kerala, it is just 2.5. So it's like 25% higher, right? And basically the people in this area, you know, they are, because we have a lot of coconut trees, so they make some threads out of it and make these kind of carpets. So the women, usually they are engaged in these kind of activities, or they work in cashew nut processing. So this is the cashew nut processing, how it may reach to, like, you know, the consumer. And the men, because this is a coastal area, most of the men goes in their boats for fishing. And some of their women, they are involved in processing the seafoods for like export and all. And the outline of the study is that totally even though according to the census we had 400,000 people, according to our study, we found that around 385,000 people in the 12 administrative units were eligible for our study. And though in 1960 the WHO asked us, 1980s we put our effort into that, and by grace 1990 we set up our baseline survey, and then we did our cancer case assessment and dosimetry. In the dosimetry, what we did is that we tried to calculate the indoor and outdoor radiation doses, the gamma radiation doses in all the houses in their taluk. So there was 71,000 houses. In these 71,000 houses, there are 385,000 people. So we visited all the houses and we tried to understand the indoor and outdoor radiation doses. Also, we calculated some house occupancy factor for all these houses. So then this is the, this I already mentioned about. So we had 191,000 males and 193,000 females. So we have a lot of females when comparing to males, which is kind of opposite to other part of India because the females are less in other part of India. So that's how we established our cohort and our cancer registry. And from 1990 to 1997, we did our baseline survey. So baseline survey is basically like our trained interviewers, like our registry staff, visited all these houses, 71,000 houses, with like a questionnaire and asked the questions to the people who are living there. So the questionnaire had questions like, socio-demographic factors such as religion. Hindu, Muslim, and Christian are the major religions or only religions in this region. And the family income is rupees. Rupees is similar to rupiah probably. And the education, occupation, and the residential characteristic. The residential characteristic is so important in the radiation study because we wanted to know the indoor radiation doses, and sometimes how the people make the houses is also important because the construction materials itself, if they have used the local products, that itself may emit some radiation, right? So it was also important to know the residential characteristics. And then in addition to radiation and other socio-demographic character, we try to ask the lifestyle related things such as their tobacco habits, whether they use any tobacco chewing, what kind of smoking they do, whether they do BD smoking, cigarette smoking, or any other type, and then about their alcohol drinking habits. So thus the 1990, we established the population-based cancer registry. Why I say it's again because this is the year we started submitting our data to the National Registry of Indian government. So we follow internationally accepted cancer registration methodology. So this is something probably new for most of you, that is death certificate only registration cases. So that is because once you, some of your, like initially when we started our study in 1919, we got 14% of our cases were death from the death certificate only, death certificate only registry entry cases. It is because in countries like Japan or United States even, they have this active registration methodology. That is, when a hospital or a hospital or a clinic or even a doctor diagnose a positive cancer case, they kind of actively register it to the national registry. So the country will have a national registry and they will directly register it to the national registry. But in case of India, we don't have that kind of system. So sometimes even in the cohort area, we can't identify the new incident cases and we come to know after the death. So that is death certificate cases. So that we collect from the registry, the vital statistic division of the government. So at the start of our study, there were around 14% of the cases we knew after they were dead. Means we couldn't understand the incidence. We knew after the mortality happened. And then over the years, the death certificate only cases proportion has decreased and 4% is quite acceptable in any cohort. And that shows our quality of the data. And more than 90% of the cases were histologically verified. And I would also like to introduce you this cancer incidence in 5 continents. This is like a book, I can say a monograph, which is published by International Agency for Research on Cancer, supported by the WHO. So this cancer in 5 continents is something like they collect the data from all of the cancer registry who has a good data. So what they do, they collect the data and they themselves analyze the data for all the countries, all the cancer registries around the world, like in the 5 continents, and put out in a book, which is like same style, like same analysis for every registry. So if you see, you don't feel any confusion in that, it's like the same for all countries or all registries. So our data was qualified for 5 countries. Even there are other Indian cancer registries whose data was not qualified for 5 continents even until now. That means that our data had a very good quality. And I was looking for, like, preparing for this presentation, I was looking in the cancer incidence in 5 continents, a recent publication, and I found that there is no registry from Indonesia, but I found some from Malaysia. So I think it will be something like you who are listening to me, who can work on in the future to make a cancer, like, a cancer registry with a good quality data, which can qualify for this kind of cancer incidence in 5 continents. And and then so far we have analyzed the data until 2017 from 1990. So as I said, it was not easy to identify the cases. Sometimes we realized that we have only death certificate only cases. So what we did is that we don't have an active registration methodology, so we follow the passive method. So on a monthly basis, our staff, they visited all the our parent institute, the Regional Cancer Center. That's where it is a government hospital, so the kind of treatment is free for the poor or very less. So in that case, our cohort area, 50% of the cases were diagnosed or treated in the Regional Cancer Center. So we visited our trained interviewers, the same people, they visited the Regional Cancer Center every month to the medical records department and try to take the data from this place and other follow-up care clinics and palliative care clinics. In addition, after knowing this, we also made field visit or house visit to these patients to know what is the exact situation. And then on a yearly basis, we also visited, our staff also visited all the medical colleges or the hospitals or, the private pathological laboratories or the medical practitioners in and around this region to find out if there is any new case, if any of these people have detected or diagnosed a new case. And then also finally, we visited the vital statistic division of the government to know that if there is any death case which we did not know as an incident case. And then twice a year to identify the new cases. So we conducted like cancer screening camp in all our administrative units. So this is like a Herculean task. It's not like in developed countries how everything will be easily updated to your computer data set. It's like, you need to work on foot to know who are the cancer positive cases in and around your cohort area. So one of the advantage for our cohort was that the migration was quite negligible, and within the administrative area, it was like inside the cohort area, it was only 9.5%, and outside the area was 6%. And usually the migration reason was because of mining or job opportunities, and 0.7% of the population were lost to follow-up. So the most important part of the radiation cohort is to have a very nice, very scientific dosimetric method. As you know, we have 300,000 people, nearly 400,000 people. So it is impossible to measure the cumulative radiation doses from birth, right? But dose estimation is necessary as well. So what we did is we follow this particular formula, which is published by the International Committee for Radiation Protection, that is ICRP. So what they said is you can calculate the individual cumulative radiation dose of a person, of your cohort member, if you know their indoor dose and outdoor doses, and if you calculate the occupancy factor. So at the time of baseline interview, our people visited the 71,000 houses. So they carried some scintillometer with them to all the houses, and they measured the indoor dose and outdoor dose, and we set up this occupancy factor. So all our cohort members now have an individual cumulative dose. So another thing is that, we have this kind of equation. We found out individual, but we wanted to confirm whether what we did is right or not. So it is impossible to ask all the cohort members to wear a badge. This is called Lexel badge or OSLD badges. So we can't ask all the 400,000 people, can you wear this? And, it's too much of work and too much of money. We can't do it. So we randomly assigned 200 people who were willing to wear it on every day on their, we made a necklace, which is like in a golden color. And we asked men and women, 50% men and 50% women, to wear this Lexel badges on their body. 24 hours a day for 2 months. So this badge was made in Japan, and then after that I bought it back. I took it to India and then made them wear for 2 months and then got it back here, and we asked the company to analyze the data. And what we got was, like here you can see that this is the OSLD data, and this is the scintillometer, the typical this one data, and we found a high correlation. That means that this method was good enough. We don't need to necessarily do the Lexel, but this was like just a quality check. What we found was good or not. So we decided to use the individual cumulative radiation dose for the further analysis. Later in 2013, of course, the other analysis was done in 1990s, but then later in 2013, we also did a carbon survey. So in a car, there was an installation spectrophotometer and a multi-channel analyzer. And the car, this is the route map. So this is our cohort area. So the car moved slowly in and around this area to check what is the radiation. And what we found is similar to what we found through the individual cumulative radiation dose. The people who lived in our previous the people who lived in the coastal area had more like this region, they had the more radiation. So it's the same what we found with the individual cumulative dose and using the GPS method. So in the same analysis, we tried to put it out like, each and every administrative unit, how much the radiation was, and this also had high correlation with our previous finding, and the coastal area seems to have more radiation. So that's part about the radiation, how we found out the radiation, and then the radiation-induced cancer, because the initial aim of our study was like, cancer, radiation causes cancer. So what happened? So we used the data from 1990 to 2006. This is the start of baseline, and until 2006, and we made a publication in 2009. And from the baseline to 2013, we made a publication last year. I will tell you the results in the next slides. So what we did is we tried to calculate excessive relative risk by Poisson regression analysis, and we use kind of lagged dose for 10 years because of the cancer. And again, cumulative doses were estimated. And this is the result of the first publication, which shows that. So here you can see cumulative radiation dose milligray. So this is 0, 5, 100, 200, and 500 milligray, right? So all cancer excluding leukemia, means all kind of cancer excluding leukemia, we had 1,379 cases. From the start of our baseline to 2006, we had 1,379 cases, and we had 30 leukemia cases. So in totally cases, for example, 812 people, they had doses less than 49 milligray, or 24 people had doses more than 500 milligray. This is the way how we analyze it. And what we found is that none of them were significantly related. So that means that radiation until 1990 to 2006 data showed that radiation is not related to cancer. Then again, we tried to do the environmental radiation dose, and it was not related. This is the recent publication in 2021. And again, the similar kind of 0, 50, 100, 200, 300, 500 dose estimation, and the relative risk showed that it is not significantly related to any kind of cancers. Okay, and separately male and female site-specific analysis, we tried to do everything, but we couldn't find any kind of association. So in site-specific analysis, no cancer site was significantly related to cumulative radiation dose, and leukemia was also not significantly related to radiation. So that's actually shows that the radiation is not related. So how much it is different from the, for example, as we all know, we always think about the atomic bomb survivor study, how much it is different from the this natural radiation exposure study. And this is like a comparison of estimated relative risk from both studies, and we put together, and we found that the Kerala study was significantly smaller than from the atomic bomb survivor study. So this is a good news for the people who are living there, because they don't have the risk of, probably they don't have the risk of cancer. At least we can understand from the data of 1990 to 2017 that they are not under the risk of cancer. So that's all about the radiation and cancer. So, but we have done a tedious work. We collected a lot of data. We had a 6-page questionnaire and we had a lot of data. So we just thought, okay, why don't we analyze other lifestyle if not related to radiation? Radiation was not related to even tobacco and alcohol related things. So we just thought, okay, take out the radiation part. Let's focus on tobacco and alcohol. And what is the prevalence of tobacco smoking in India? It's 26%, and it's quite low when comparing to other. This is according to the WHO report in 2009, during which these studies are conducted, and it is quite lower when comparing to other Asian countries. I think in Indonesia it is like 61%. This is another thing, maybe you should work on it on a later stage. So I would also like to introduce you some of the popular, the smoking thing. I don't know, in Indonesia, do you have this BD? Probably not, right? Yeah. So this is BD. This is called, poor man's cigarette. Why it is poor man's cigarette? Because 25 BD costs only probably 735 Indonesian rupiah. It's quite cheap according to Indian money. It's just 3 to 4 rupees. And the years ago, people used to think that, okay, if you can smoke BD, it is like, have a social acceptance and respectability in the culture. And cigarette, obviously, it is so expensive, so everyone can't access it. And you see the packet of cigarette, it is like, very scary. But for the BD, it comes with beautiful picture, like a prince, prince or a king, like kind of picture on the top. And it's kind of still, BD is very popular, or just it's there in the society. BD has more hazardous than cigarette. That is where, we need to create our own data. It's so important to know that, BD is only in India possibly, or maybe some few countries near to India. So usually all cancers, we have the data that, okay, lung cancer is related to cigarette, or esophageal cancer is related to cigarette. But when we checked in our data, we couldn't find that, Cigarette is not related to esophageal cancer or some other cancers. Why? Because BD, people were smoking BD, not cigarette. So it is always important to have your own data set to understand how the real deleterious effect of the, some habits which is prevalent in your society. So BD seems to be more hazardous than cigarette because it has higher concentration of toxic elements. It has 3 to 5 times more nicotine and other things, or 1.5 times more carcinogenic hydrocarbons. It has low combustibility and porous nature. So people, the smoker need to take frequent and deeper puffs. So it's like if a BD smoker take 5 puffs per minute, the cigarette smoker may take only 2 puffs per minute. So that means it's more hard for the lungs of the smoker. Then the next one is tobacco chewing. I don't know. I would like to hear maybe later that whether in Indonesia the tobacco chewing is prevalent or not, because I saw the prevalence of tobacco use. It's quite high in Indonesia. So our cohort area, this is called, the green leaf is called betel leaf, tobacco, slaked lime, and arak nut. So these 4 combination, they make a bolus and chew it in the mouth, and then after some time they spit it out. So this is how our cohort members use this tobacco chewing. And IARC in the 1985 combined this tobacco and arak nut together as a carcinogen. But still, people in this, it's a part of our culture to do the tobacco chewing, and this is more prevalent among the females in Kerala. That's one of the sad things, because the females in Kerala, they don't smoke, but they do tobacco chewing. So it's more, we need to study more about the effect of this in women. And this kind of commercially available one is also available, but people tend to eat more. At least in our cohort area, this one is more popular. So because Kerala has a lot of coconut trees, the alcohol which is made from coconut, called toddy, is the most popular one, and the alcohol percent is just 5%. And the arak, usually it is from the cashew fruit, the distilled from the cashew fruit, and it can, I don't know, it's not certain 50%, it can go even up, because arak is banned in Kerala state, but people tend to distill their own, so we don't know the exact concentration of the alcohol. and other foreign liquors are also very popular. So in our data set, we had the data of BD, cigarette, tobacco chewing, and alcohol, such as like how many numbers they do smoke, or how much quantity they do use, and how long they have been using, or when did they start to use this thing, or when did they stop to quit. And then after that, we try to analyze the individual effect, what BD can cause to cancer, or what cigarette can cause to cancer. Or sometimes you might have heard that the people who drink alcohol tend to smoke cigarette at the same time. So we try to do the combination effect of these things as well. So as you know, we have a wide variety of cancers. It was like initially, what should we pick up and do the analysis. So what according to our cancer incidence data, we pick up the highest cancer incident cases in our cohort, and we try to analyze that. For example, in case of mouth, we analyzed for both female and male. For lungs, we analyzed for lung and female. But for the others, the cases were so small, so we couldn't analyze. Maybe over the years, maybe we can analyze. But at this point, we have to analyze only the effect on men. So in the inclusion criteria, we thought about all of our cohort members who are the age of 30 to 84 years. And among that, around nearly 70,000 men and 81,000 females were there. And we excluded people who work in the mining industry because they may be related to radiation. So, and what we got is that, so I cannot, I mean, 45 minutes is not enough to talk all the results of our finding, but still all the tobacco related things, we found that tobacco use causes lung cancer in men, females, oral cancer in females because of the tobacco chewing, oral cancer in males, and hypopharynx and larynx cancer was caused by BD, not cigarette. And gastric cancer again caused by BD, esophageal cancer caused by BD, not cigarette. So our cohort is the first cohort study in India or South Asia to show the significant association in a very large number of data set. So if you like to see the results, the sub-site analysis or histology analysis related to each tobacco use, probably you can just see our Karnataka cohort publications related to each one if you are interested. And then related to alcohol use, again, toddy, the alcohol which is from the coconut tree, was not related to any of the cancers, but we found that hypopharynx, larynx, gastric cancer, and esophageal cancer was related to arak, though arak is a banned thing, And then next is about the breast cancer. So we did a small case control study with the incident cases. We pick up the incidence cases in our cohort. And using our questionnaire, we found out that it's already known factor, the number of no pregnancy had more risk. And as the number of pregnancy increases, the risk tend to go down. And among the people who had more than 5 times of roots and tubers conception per week, or those who used chicken and those who drink milk regularly, they tend to have more increased odds ratio, more risk. At the same time, tapioca, I was seeing in the previous slide presentation about the cassava. So we actually in Kerala, it is kind of a staple diet, like 2 to 3 times in a week, we eat a lot of tapioca or cassava. And it seems, it has a negative effect. So this is a very good finding as far as I am concerned, because usually we have a saying that if you eat a lot of cassava, you tend to have more thyroid nodules. But at the same time, it also shows some protection or negative association for the breast cancer. So we did this kind of analysis in post-menopausal women and premenopausal women and found the same kind of results. So that's all the story of cancer. And let's move on to the other radiation-induced diseases, which is like cross-sectional studies done in the cohort area. That is like the thyroid, cataract, and arteriosclerosis. Arteriosclerosis means cardiovascular risk. That's what I mean. So the first one is thyroid diseases. So As you all know, radiation exposure has been reported to cause thyroid nodules. Because the thyroid abnormalities are common in women, this study we focused only on our women subjects in our cohort. So we did an interview with a questionnaire, and then our thyroidologist, he conducted ultrasonography of the thyroid, and we also took the blood for the serum assays to find out the thyroid hormones. And then we used the cumulative dose for calculating the radiation.
Atira,
Yes?
5 more minutes.
Okay, thank you. And then what we found is that solitary solid nodule, thyroiditis, and hypothyroidism, we follow the same kind of, the analysis. And what we found is that there is no increase of these diseases in related to high natural radiation exposure. And the third study is about the cardiovascular risk. So it's impossible to, completely analyze the cardiovascular risk among the general population because they are not sick yet. So what we did, we pick up the arteriosclerosis as the main cause, and we tried to pick up the cardio-ankle vascular index, CAVI, and intima media thickness, IMT. These two indexes are the end point of arteriosclerosis or cardiovascular diseases. So initially, probably you all know what is IMT. So it is like a common carotid artery. So we check the the layer between intima and media, two important layers of the artery, and which we measured it using an ultrasonography to check the thickness of it. And that's an ultrasona, and we calculated mean IMT values from the 16 values. And the next is CAVI. So CAVI is a method proposed by Japan, and they basically depend on the aortic stiffness and brachial ankle pulse wave velocity. This study is already known as the CAVI index, has some high correlation with aortic stiffness and carotid arteriosclerosis. So we use this IMT and CAVI as our main indices. So this is me doing the CAVI probably 12 or 13 years ago. So the patient will be asked to lie down, and we put a lot of things on their body and then try to check out the CAVI index. In addition to checking IMT and CAVI, we also did the epidemiological data collection, laboratory assay with the blood from them, and weight and height, because CAVI machine needs that. And what we found is very, very interesting, that the adult dose, that is a cumulative dose, is significantly related to radiation. So that means people who are living in the radiation area can have cardiovascular disease, right? So even after adjusting for all the blood biochemical parameters, it was significantly related. So this is a very big finding. So arteriosclerosis can be caused by natural radiation exposure. And then the next is about cataract. So we had 840 women who underwent lens opacity classification system using a slit lamp by an ophthalmologist, and we also use the lifetime cumulative radiation dose. This is not a published data, so I'm currently working on it. And as we expected, radiation causes cortical cataract, as you see here. So among the people who are exposed to more than 200, the odds ratio seems to be quite high and statistically significant. So it shows that cortical cataract, it can be caused by high natural radiation. So what are the advantages of our study? So the people in this area are infrequent medical exposure. They are homogeneous population. They have a low migration rate, and we have the information on their lifestyle of all our cohort members. And our data is from the cancer registry. And the limitation is that the internal exposure is difficult to evaluate. And because we checked only indoor and outdoor, right? We don't check the internal exposure. And the occupancy factor in the past are difficult to know. So this is the summary, that high natural background radiation exposure, our data showed that no increased cancer incidence, no increase in thyroid nodularity. Thyroid nodularity is something which is like a pre-stage of thyroid cancer. And then it also causes arteriosclerosis and cortical cataract. And alcohol and tobacco use causes all of these type of cancers. And then the final part is that, we have been working from 1980s until now. And the best thing happened to us was our data. Probably it is good data. That's the reason I guess. Our data qualified for the United Nations Scientific Committee on Effects of Radiation, Atomic Radiation, working committee meeting. So what they did is that they analyzed all our studies with our raw data set, and they analyzed and they prepared a technical report about our studies and put it in the scientific annexes in 2017 and 2019. This is where I think if you have a big data set of your own people or your own population, it is important that you can show to the world that you have this kind of data, and then they accept your data and try to use it as for other people who live in high radiation area in this case. So previously, before this study, we know occupational, diagnostic, atomic bomb radiation exposure, but natural radiation exposure, not so many studies are there. So I think our data has a very big role in Society 5. And why? Because our data is so rare and we have a very big data set that is like a contribution to the society. And because of the cohort data, it has single or multiple exposure, but you can study multiple outcome. We can analyze incidence and prevalence. We can detect early diseases. We can predict the trend of diseases and create prevention measures. And we are also part of cohort consortiums like, Asia Cohort Consortium or Concord. And we also contribute our data to the National Cancer Registry Program of India. And the thing is that we have big data sets, so we can collaborate with anyone and we can just put our energy now for data analysis. And we are also part of many policy making activities, such as anti-tobacco measures in India and cancer screening programs. So with that, this is one of the challenges we also had is finding the money for the study. Initially, it was supported by the WHO or the ICMR or even the India government, but later on our way, we also got the support from the Japan Health Research Foundation and Central Research Institute of Electrical Power Industry in Japan. So yeah, we also had many challenges, but we tried to overcome. And thank you for listening to me. And I also have one more slide which shows that, do any one of you know that in Indonesia, there is a high background radiation area? That is in Mamuju, Indonesia. Probably some of you know, but I don't have time to explain a lot about that. But anyway, if you like to read a bit, please find their publication. This is the same study group of us. Thank you.
Thank you. Please give a big round of applause for Atira. Wow.
Thank you.
Atira, I have to say that, honestly, this is the first time I heard about low dose rate ionizing radiations, and this is also the first time I heard about natural radioactive and natural radiations exposure whatsoever. And when you gave me the last slide of yours, it's like it struck me in my tummy.
Oh, the Mamuju one, right?
Yeah, this is really the first time I heard about that. So
okay,
many thanks for sharing.
Yeah, there are so many publications from Mamuju, but very late, recently, like from 2012 onwards, our group has been working on that area.
Ah, okay,
Yeah.
great. Before I go further to questions, maybe we have some questions here. I would like to say I love the coconut leaves mattresses. They're so beautiful. So vibrant
Okay,
in
thank
colors.
you.
Okay, now is there any questions from your dearest friend? Dr. Anja is raising her hand.
Yeah.
I
Oh,
get-
she has a question. Anja, Duta,
Yeah.
Pulong. I have so many friends there.
Ah, yeah. I hope I can be your new friend here.
Oh,
Okay.
yeah, sure.
Thank you. Anja, Mbak Anja, Dr. Anja. Mikrofonnya. Where's?
Hello, dear Artira. Hi.
Hello, Anja. How are you?
Fine. I hope.
Thank you
too.
so much, actually, for inviting me.
Thank you very much that you can do the presentation. I have
Thank you.
2 questions.
Okay, go ahead.
A serious one and not serious one.
Okay.
Which one? You
Welcome,
prefer?
both of it.
Okay. Not serious one. When will you come here to Indonesia? to
I
meet-
have a
we
real
want
plan,
to
but
meet you in
but probably
person.
next year because Dr. Saikol, he said to me, don't go to Indonesia until he is back.
I
So
see.
2024 possibly. Yeah, I will make.
Okay, so I hope we can meet soon.
Yeah,
And
yeah, sure.
serious question is, you have a lot of data, cohort data, with big data. So my
Yeah.
question is, how to manage the person, the respondent who involved the participant, so we can prevent the loss to follow. Because your research is conducted for many years with
That's
like
true. That's true. You know,
thousands
the one of the loss
participants.
to follow-up is a big problem for us. But according to, the international many cohorts, our loss to follow-up is quite low. Probably because it is a semi-urban society. It's not like a big city or something, People know each other. So even it's
Yeah.
the chance of getting lost is a little bit less, but we don't know now because because of the corona, things might have
Yes.
changed a bit. So it will be like, right now we paused our cohort activity for some time. Cancer registry is going on, but cohort activity is paused for a while because the India government said don't visit the houses because we may bring the corona to them. So because ours is also hospital, right? So they don't want
Yeah.
hospital people to enter their houses to ask questions and blah blah blah. So we had to stop for a while, but maybe that's a big challenge after the post pandemic era. But previously we did not have that problem because we kind of double check in many way. That is the advantage of passive registration, because passive registration means you go there, you talk to that person, you talk to the next house, next house, next house, because all of them are in the cohort, right? So our society is something like that. They know each other.
So it's
So
like
that was not difficult in the previous time. That's why our loss to follow up is just 0.7%. But that's a very interesting question because in every cohort, that's the biggest challenge, especially in big cities.
so it's depend on the community. You mean that
I think
in
so. I think so. And
rural
your
communities?
methodology, most of the places it is like active. You just phone call them, or, because going to houses and checking everything cost a lot of money.
Yeah, that's right.
You need one staff for that forever because it's a everyday process.
Yeah.
And you need to yeah, that most of the people they don't want to do, but because we wanted to have a quality data, so the India government has kind of they had this definition that it should be good quality because this is for a special purpose. It's not like any normal cancer registry.
Do you
So we
give
wanted to make sure. Yeah.
like some incentive or maybe like some money for the
Mm-hmm.
participant or?
No, we haven't given them any money actually. Our cohort members, they don't get any money except for the fact that they get free cancer screening in because this is our institute. Yeah, this cancer registry comes under Regional Cancer Center, which is our parent institute, which is supported by half by India government and half by Kerala state government. So it's kind of free, the cancer treatment is kind of free for the poorest. So a little bit you need to pay for if you are a little bit rich, but yeah, so that kind of treatment and their screening, if you find screening something, we will immediately put them to our main institute, parent institute, and they kind of go through the treatment in an early stage. So they are quite happy and they know that because mining has been done for centuries there. People know that if you live there, you have some risk. So they also want to,
So for their health, their own.
take care of their health.
Yeah.
Yeah.
Yeah. Thank you
We
very
have
much.
never given any money.
Yeah, for the information. We need to
But
learn
again,
from you.
doing cross-sectional studies, it is a challenge, Ansha, because when we want to do cross-sectional study, we want to invite them to for example, when we do CAVI, or you have also done CAVI,
Yeah,
right?
CAVI.
So doing CAVI takes a lot of time. IMT
Yeah.
takes a lot of time. So we have to invite them from their homes to our, the clinic,
How to make
the
them
main
come
hospital clinic. So that is
voluntarily?
again challenging because we have to send them a car.
Okay.
That we need money. Yeah, that we
Yeah.
need money. Yeah.
Well, thank you very much for the explanation. I hope
Yeah.
you can make something like similar.
I
don't
really
know
think so.
when.
Because when I saw the cancer incidence in 5 continents, I was really surprised because another speaker from Malaysia, I saw there are cancer registries with good quality cancer data from Malaysia and from other countries, but unfortunately, I couldn't find from Indonesia. So I think you guys should work on it.
Yeah, it's a good future
Yeah,
research, yeah, for us.
yeah,
Thank
I think so.
you. See you soon.
See you. Thank you so much for the question.
Yeah.
Thank you, Dr. Anta and Natira. Another second stroke to my gastric. We have to do cancer registry. That's what we're trying to working on right now.
Yeah.
I'm a surgeon, and
Oh,
it's
okay.
not. I don't know why it's always difficult to collect data here in Indonesia. And again, this is the first time I heard about the smoking incidents above 18 years old for males, which is the highest among all the other countries you have. And we're not included in those cancer incidents in 5 continents, blah, blah, blah stuff for years. So,
Yeah, but that is because you need to have even
Yeah.
for India, we have people who are trained in IARC or WHO, particularly to make how a good quality. You are eligible, you can apply for such kind of scholarship and go and get trained.
I really think I'm going to contact you further for this cancer
Yeah,
registry.
yeah, sure.
And definitely going to bring these slides to my colleagues in the
Yeah.
hospital to start really doing the cancer registry.
Yeah.
So, is there any other questions from the audience in the Zoom room? Ada pertanyaan Zoom room? Gak ada. Is there any other questions? Talking about cassava, Tira, do you
Yeah.
have any specific method to consume it?
Cassava, actually, we usually do in 2 ways. One is boil and put some, mash it like a potato mash. We mash it and we eat with fish curry, for example, instead of rice.
Okay.
Another way is we just boil it and eat with chili sauce or chili chutney. I don't know what you say. Yeah, chili sauce
So
and then
boiling
dip it. Just boil it like white and then cut long and then just dip it and eat it. It's my favorite food in the world.
Okay. Preferred more than frying. Okay, we have one question here. Mas Anton. A moment, Atira.
Yeah, it's okay.
Good afternoon. First of all, let me introduce myself. I'm Arfadi. I'm a medical student of University of Jember, and my question is, how we supply or manage a good data for epidemiological cohort research? I mean, is there any requirement type of data we need? For example, that it's just auto ratio is enough for we need additional data for the cohort research. Thank you.
That is actually a big question, but thank you so much actually to ask that kind of question. But it's always depend upon your purpose. So the data for cohort is totally different from data for a cross-sectional study or data for a case control study. So it's completely depends upon what is your final outcome. So in our case, when I mentioned our questionnaire, I mentioned that in normal cohort study, we don't ask questions like, how did you make your house? What kind of materials did you use to make your house? So that depends upon what is your purpose. So, and regarding the quality, the quality is so important. So that's where I mentioned previously also, that most of the cancer registries, even in India, they don't qualify for a high data check because you really the chance of you get lost, lost to follow up or some of the data is missing. It's very high chance because you send some, and especially the trained interviewers are very important because before they come back from their house, from these houses, they should know they have all the data or not. If not, they have to go back and get it. So that is like kind of a tedious work, but it all depends upon your, you need some kind of expertise. You can't make your own some questionnaire and go with it. Then you, after 10 years, you realize, oh, I don't have this information. Many people say to us that we don't have the information of BMI. It's usually in the cohorts, like I work in another cohort in Japan, Japan multi-institutional cohort study. They have the data of BMI, which is one of the basic thing any cohort study has. But in India, we don't have. So that is kind of, pitfall in our data. But when you see in a bigger picture of 400,000 people, every single person in the house, all our cohort members, calculating the BMI is so tough. So we have to sometime, let it go of some things, but pick up the most important things. And that to pick up the most important things, your team members need vision. That's all I can say.
Yeah, yeah, we got it. I hope you also got it. Yeah. Thank you, Atira.
Yeah.
And for extra informations, we also have similar thing to BD smoking and betel nut chewing.
Oh,
yeah,
okay.
that is
So,
another.
so I should have
to take
avoided
on.
those slides and
Yeah.
save my time. I did not know because, in Japan, people usually, when I talk in most of the studies, they say, what is BD? And,
Yeah, we have sort of, not like really like that, but sort of. But the betel nut, yeah, we have it. So if there's no more questions, okay, we got no more questions, and my personal question is gonna go straight to your email after this, inshallah.
Okay, go ahead.
Yeah, and for the comedy, would you please share Atira's certificate? We're gonna give you a certificate. A moment, we're working on it. Sorry, Atira.
No problem.
How do you know that your environment has those stuff? The natural
Yeah,
radiant.
because our sand is quite dirty or whatever. It looks very dark. So like in 80s, we send this square products, the carpets and those kind of things. That was taken to Germany by ship. And one of the German person, he was a scientist. He saw this black sand on the carpet, and he thought, what is it? And then he checked it in his laboratory, and he found that it is monocyte. So that's how the news reached them. It was like accidental, and from then we have been doing the mining till now.
Okay, so this is your certificate, Atira. This certificate is presented to Assistant Professor Atira Nandakumar, PhD, as a speaker in the international webinar, Society 5.0, a new chapter and opportunity to agromedicine. Big round of applause for Atira.
Thank you.
Thank you so much. Hope to see you around.
See you. Thank you.
Afternoon. Have a nice day.
Thank you so much.
Okay, moving on to our last speaker. Have we already got Dr. Watasit Siriwong with us today?
Hey, I'm here.
Oh yeah, hi.
And you here? Hi. Good morning.
Good morning.
Lunch in time. Okay.
Yeah, I haven't seen you yet. Wait for a second. Have you put your camera on?
Yes. Can you see me?
Wait a second.
I think I see everyone here.
Okay, yeah, that's important stuff. Okay, well, I would like to share your short curriculum vitae for a while. The comedy will help me to share it on the screen so everybody can read it. But I'm gonna read short about you. Dr. Atiras, Associate Professor, Dr. Watasit Siriwong, PhD. Currently, you're working in Public Health College of Public Health Science in Chulalongkorn University in Thailand. This morning, you're gonna bring us some topic about children risk, new challenge and opportunity to agromedicine. Is it correct, Doctor?
Correct. Yeah.
How can I address you, Dr. Watasit, Dr. Siriwong?
Anyway, you can say what is it? It's good.
You have around 40 minutes to bring us your slide. Please, Doctor.
Thank you very much. And I share the screen.
Do you want to share the screen from here or from your own computer?
No. My own computer is better. Hopefully now everyone can see, right?
Yeah, we can receive it now. Yeah, we can see it clearly now, sir.
Okay, thank you very much for introducing me. First of all, good morning and lunchtime. This is lunchtime in Bangkok, and I think this is the same time in Indonesia too. And very happy, really very happy to talk with all of you today. So my topic is very challenge, is related to our new futures. It's our kids, this, and also pesticide that is one of hazards that we in Southeast Asia, in Asian country, we use a lot compared to others continentals, right? So when we use, sometimes we uncontrolled, we use a lot. We don't know about the toxics of the pesticide very well, and finally, students maybe the one that exposed and get the health effects. Today I would talking about this with the times 40 minutes allows, and this is the challenges and opportunity to agromedicine. The wording agromedicine, you may know when we're talking about chemicals in farms or in the agricultural systems, that including all chemicals, include the pesticides. This is one of the book chapter. Actually, I have about four books that talking about pesticides, and the picture that I taken is come from northeastern Thailand, where they grow a lot of the chilies and export to many countries, and also in country we also consume ourselves. And pesticide is one of the products that contain a lot of pesticides. And why we're talking about this, since we're talking about students, because of their house live in farms, and many kids, many students stay in that house and also exposed to the chemicals, because of, like in Southeast Asia, we don't have the zone, like the zoning compared to the in Japan, in European country, or in the US, they have zone for residential zone and agricultural zone, but we live in farms. I think these characters is same like in Indonesia and also in neighboring country of Thailand, like Laos, Cambodia, and Myanmar. And we expect, we doesn't like to expect this adverse effect, but the kids exposed to chemicals directly. So the books of these mentions about pesticide, that's long history that we use a lot in the agricultural systems. And since, if we remember, in Egypt, in Egyptian scripts, and also in China, that use like heavy metals as the pesticides, like arsenic, for example. So that means the one reason that we continue, we use pesticides, and once we know the effects of pesticides, when the movement happens, it's about 1950s that we have DDT in this beautiful world. In the world, we Professor Paul Muller's, Dr. Paul Muller's produced one chemical named DDTs about 1950s, and then later on, Rachel Cousins, she mentions about the effect to the environment, impact to the bird that we have, that they will have the book named Silent Springs that says about why in that spring no bird sounds, and then we know about the effect because of pesticide use. And finally, when developed by the times, we know pesticides is this kind of pesticide that contain choline, or we say cholinated compounds, can cause cancers, and it's banned for some kinds of chemical that contain choline in Stockholm Conventions, that we say POPs. And pesticides, the first synthetic pesticides in the world, and derivative has been banned because of that. And now we don't use chemical that contain with chlorines according to cancer in long-term exposures, and more specific for DDTs for reproductive systems. And that is the reason that why we ban of all chemicals that contain with chlorine. And when it's banned, some illegally use is still because the price is stopped, and some stock in their house, in their farms, and still use because once you spray once, it can cover for your one crop maybe wrong because of properties. By the way, at that time, formulas get the Nobel Prize for help people for malaria because of the purpose of that time is control pest. And we know the effect later on. And anyways, I would like to talk that when we're talking about risk, we have to balance between benefit and risk. As I showed the one of a good example, we get DDT to keep humans' life to provide to protect humans for the exposures and protect of the malaria at that times. And then finally we found the effects of cancers. So look at these pictures. This is come from the WHO website. When we're talking about pesticides that I have introduced to you, and it's toxic chemicals, but the hazards or the toxicity depends on kinds of pesticides. Nowadays, we ban organochlorine pesticide or chlorinated compounds out of the list, and we have a new pesticides. The new pesticide that we use nowadays is organophosphate pesticides and carbamide. And also the newest one, the youngest, is pyrethroids that we use in households. And when we're talking about this, my frameworks that now we should focusing on the organophosphate pesticide, carbamide, and pyrethroid. That because of we are using it around the world. And for the chlorinated compounds, we still detect and we look at the long-term effects, long-term effect that after ban all kinds of those chemicals, but not pay attention too much to that. So the WHO mentions about the reasons about toxicities and health effects and dangerous, especially to the women and students, because this group is one vulnerable group that we have to focusing on. Students would be our futures, and you will see later on. I have many slides that show about neurological effects to students, and if they have problems since they are still young, they are our future. So what will happen with this group when they grow up? And like we are getting on day by day, and we still need the new future that's strong and be our hope for do better things. And the other reasons that still found in many research that talking about suicides. And people sometimes suffer from something. They use pesticide for suicides. That is not good things. And the other research that found in farms area is death from direct exposure, especially for students, because students play in farm. Sometimes they expose to the chemicals on the ground, and they put some like soil, some dirty hand into their mouth, and dead. Many cases report in Thailand. Also, we found these incidents and cases that death from exposed directly by eating of soils. This is the pictures that I show to you about the characteristics of the farms. Most of the farmers do practice of chemical like this, mixing and loading nearby the farms. And if, like you know, we are the countries of rice, live farming is allowed the countries, and when they do mix, they use the waters from the small canals that you can see, and sometimes it's contaminations. It's contaminated to the systems, and these canals, small canals, connect to the big rivers. Ismail River of Thailand is Chao Phraya River. This picture taken from the central part of Thailand. And where pesticides go, finally it's go to ourselves because of by the systems, by the food chains. And the other examples, this is taken from the northeastern Thailand that allow the chili farms. When people use the pesticides, they throw about the products allows the farms nearby, and it is go to the depth of the soil, to the groundwater systems, and spread because underground it has connected by the water system underground, and people in farm still use the groundwaters as for drinking, for utilize for others. They use that is exposures. So pesticide is long history, like in Thai, in several countries since they are start produce 1950 period. Now, if you look at this graph, that you can see it's go up and increase by the times because we use it as the protections of the crops, and the belief of the farmers that in farm, they believe the more that you love that the more that you love to use it, that means increasing of pesticides used in farm. It means increasing of the product that you may have. So it's still sprays and believe that if the more spray, you get more product, more use. So that is a cause of increasing of use. Even the government try to promote to less use or stop use some harmful pesticides. But if once we do like interviews, we still found these some kinds of reasons. And as I have mentioned nowadays, not just only in Thai, around the world, we use organophosphate pesticides, carbamate, and pyrethroids. Pyrethroid is the newest one. Because of the newest one, the price is still high when compared to other two groups of pesticides. In two groups of pesticides, many kinds. This is we talking about groups of pesticides, many kinds, but mainly organophosphate contained with phosphorus and carbamate contained with nitrogen forms. So we look at this. The use mostly go as the insecticides to protect the crops from insects. And once when farmers spray pesticides, mainly in farm, because this is high dose exposures, if we use in-house, we use pyrethroids, and I have the research that mentions about pyrethroids in-house, household use, and both in farm too, because when applied to house, when applied to farm, the kind is the same, but the amount is different. Small amounts of chemical spray like in household, but big amounts may spray in farms. So go back to organophosphate pesticides and others we use in farms, and sometimes farmers take it from farm to house, and the house characteristics like in Thai, in Southeast Asia, is a 1 floor or 2 floors house, and farmer mostly keep it in house, and once pesticide is easy to evaporate. Farmers can feel, even the literature, when we go to the farms, we smells of the pesticides in house. So that means if that house have the kids directly exposure for 24 hours, if they still lower age, 0 to 6 before go to the schools or to 7, depends. So that means all day, all night they exposed to those kind of chemicals. If it destroys your nerve system, neural system, that is the problem because of the development of the child from 0 to 4 years is very important. After this, it cannot change anything. If you have a good environmental settings in house for the kids, the neural development, neural behavioral development would be better compared to if you exposed to some kinds of chemicals and your function is malfunction at that time, cannot change after 4 years. So that's why the recent one. So in our wet seasons, a lot of pesticide use in herbal as well. In herbal as well, we have some kinds of fevers, dengue fevers, like it's common sprays like in households, and for the government as well have every routine spray of pesticide. Even the toxicity is now shown to be the lowest toxicity, but still have the toxicities, but it's just easily to degrade. For example, like pyrethroids to control mosquitoes and cockroaches and other insects. That means all the year round, both in urban and rural settings, we use, but use amount of pesticide is different, but different, and also cause the long-term effect is different as well. That look, WHO has mentioned about these concerns for long times about the hazards and exposures of the chemical to children and can cause the like illness, and children become to be susceptible groups around the world. And if when you look at the factors and look at the risk assessment, you may use a website like US EPA as the reference. That one is a good one for reference for specific exposures. Even like in Asia, we try to develop our scenarios, our factors like exposure factors. It may take a long time. Many years ago, before COVID, I have invited to do some kinds of this, like in a groups of the pesticide membership in China, in Korea, to setting up some kinds of factors that more reasonable to Asian country, like body weight, exposure durations depends on the occupational times. Like we have different from like in the US that have the like scenarios from exposure and from their surveys. It's more correct for when we use for predictions, for prediction in the futures. By the way, when we talking this of the students have exposed to the chemicals, you can imagine like when kids live in farm 24 hours for many reasons that I talked previously. And if mothers have pregnant in farm, that means they have exposed. We have the state of life when we do about the research of students, at least lower force and up to 18 years, but mainly focusing on lower force. And we look at preconceptions before have matings of the sperms and egg, and then we can continue the research by the series of the times until they have deliveries. And for the students, after delivery, we can detect the concentrations detect the behaviors of the children since they deliveries and 1 year to 4 years. Now we have the method and procedure to do like that. And look at this, that the state of life very important. That's why in the last, maybe near the last slide, I talked about the development and the activities. Activities is very important for the exposures of the kid. That is the challenges of the research. You can imagine if like in Times magazine is popular, right? They mentioned about 2010s now, they're talking about the pregnant women's getting risk from exposures of kinds of chemicals and talking about the first 9 months is very important now of the rest of the life in that their bodies in human body, that means their kids since they have still in their bodies, and so that means children expose chemicals and I let you imagine in farms, mothers who pregnant and they still work in farms, still use pesticides, spray by themselves or let their husbands to spray. By the way, they work each other together. They expose the chemical in house 24 hours exposed. This is the reasons that major reasons of the exposure of the children. It's challenge for all the research that look at the children. When we're talking about risk, risk is two components, is main components, hazards and exposures. Actually, we're talking about hazards of pesticide. Pesticide have hazards because it has toxicities, and children exposed with kinds of route of exposures, like breathing, eating, and by the skin. This is direct exposure that many research and we focusing on. And this is the theories from National Academy of Science of the US that talking about risk and relate with US EPA. That talking about risk is probability or the predictions of the harmful effect when people exposed to the chemicals. Hazardous chemical is the concern of this, because if we're talking about hazards and toxics, since Paracelsus, the fathers of the toxicologists, that talking about all those have the poisons, depend on those. That means more or less they have toxic. For example, if you consume sugars have, the more that you consume sugars, that means the weight that you can gain. But if you don't eat the sugars, you have no energies for serving your life. So that means depend on the dose. Depends on the dose. And this is simple with others risks. For example, like sunlight. The more you expose to the sunlight, your skin would be dark, right? That means can cause the cancers. That means if we need to reduce the dose, we may reduce from exposures, because if you reduce at hazards, it's sometimes difficult. Like, for example, sunlight, if you reduce how to close the sunshine, cannot, right? So like in farms, we can difficult to say to the agriculturists or the farmers stop to use of pesticides. They don't because if once insects come to their farms, sometimes one overnight, the farm is gone. That means the monies or the benefit that they lost a lot. They use. So we try to have many programs to introduce them to reduce of use or use correctly, because educational levels for the farmers, like in Thailand, it's still not too high. It's low to moderate, but mostly our people is low educated. And they listen to their neighboring, like listen to the company that promote to use pesticides. So that is the one reason again to the use of pesticide in farms. For children, exposures as in the farm, we found in daily from air, from food, from dust, from soil that they pick up some the soil into their mouths, or we say pica, P-I-C-A. This is one of the children's behaviors, that they put some object to their mouths, including for toys. If toy in house and use pesticides, this happens most of the research in house pesticide exposures. We collect the toy that children usually love it, prefers of that toys, and detects of the chemicals on the surface and use the theory of risk to predict of the risk of the students. Anyways, for long-term exposures may cause cancers or non-cancer effects to the children. Depends on what kinds of that chemicals, depends on the dose of that chemical that students expose. And if look at the by dietary, by consumption, eat food of children that they eat in farms, most in farm they bring allows from the plant that goes or buy from the market. By the way, it's mostly contained with pesticides, and it can even nowadays some kind of pesticide is easy to go leach out from the bodies, but still have the residues, and because of continuous exposures of these chemicals we detect of kind of chemicals usually found in children by urinary metabolite, because of continuous exposure in farm, even in house. Some of those of chemicals still found of pesticide in urban use and have some effects to the children's. We talk later with the research. And by the times that we're talking exposures, we look at three main things, like intensities that mean for the dose, chemical concentrations, and duration of the times of the kid that exposed to the chemical, and frequency of use. You can imagine in farm maybe use every day. In house depends on use of the household member that they use, and they found some kinds of insects they use occasionally use in some house. So this is important for the outcomes of the children's is frequency of use, concentrations, and time durations that they expose. And as I mentioned about the root of exposure, this is the root of exposure that we always talk in risk assessments, and also use for predicts the effects. Now, when we're talking about effects, we count from the beginnings of exposures to the effect. This is the times we say this is latencies of the exposures from exposed until you observe the effects, and more challenge for all the research. This is the thing that you can predict. The things talking about the environmental health frameworks from the chemicals exposures, and go to the human body like children's, and you can detect from their pathways, from the dose of exposures, from the biomarkers like urinary markers that you can see the metabolite. So the effect can cause at the acute and also the chronic effects. This is the thing that we concern a lot of the effects, because when we see the effects, some effect cannot solve it, like delays of the neurobehavioral examples, we cannot, or if death happens, we cannot resolve it. So prevention is needed. When we do about exposure and assessment, this is look at the characters of the house. Nearby the house is the farms. This is my professor, Mark Robson, and the team that we do usually do the research in farms. And you see in-house, the grounds is soil, in-house, the first floors, and they have like one furniture, one living place for the chair, that they still spend times on the chairs with the gardens, for example, grandmothers, grandfathers who stay at homes. And this is when we do exposure, we integrate, we do all those of exposures that we say this is aggregated exposure assessment from all sorts of exposure and all pathways, all the pathways of the exposure. Even some kids go to the schools, we go to detect of the exposure from the skin. If you look at the picture nearby, we do the research, and we do easy way to do the research with kids is when they sleep, and look at these pictures. It mentions about the farms, the house nearby the farms, and in-house, 2-floor house, and they keep some stuff, even pesticide nearby, and people and students play on that chairs, big chairs, and spend times on the chairs and plays. And a lot of house usually in urban that use the pesticides, like mosquito coils, for example, spray pesticide, but in farm, no need, because every day they sprays, and in the house contaminated with pesticides, and mostly compared to the urban settings. The purpose in-house use is less than. And look at in-house. Yes.
I'm sorry, you only have 5 minutes left, sir.
Okay.
Okay.
I can move. I can move. Okay, yes, look at this one. Look at the aggregate exposures. Now look at this. It is in the classrooms. Now the characteristic, I think, same in some areas of Indonesia, and this is the effects of toxics of kind of chemicals that I have mentioned, both acute and both chronic effects. So if high concentrations, it has the effects up to indefinitely until the lethal consequence. You can look at the table later on. I try to put manage. And for the chronics, is the problems. Neurobehaviors and cognitive deficits is the problem to the students. Look at this with trends, and we have the research with students with about the ADHD projects, about the brain, about the effect of exposure of pesticides in farms, and we have the funded from the US to do of that research. And this is very important. If one of the challenge on the research, by the age, by the single period of the times, you can do cross-sectional studies by the activities of the kids. Look at the kids, and then look at behavior for specific, like tigers, put some objects to their mouth. So this is the thing that would be interest for the research for the farm areas. And look at this one, even not related with the students. Many research confirm, and this is the research in Myanmar, me and the students that do with the farmers, with the reproductive problems with the sperms. And we found that new pesticides in the past, we say about chlorinated. Now, organophosphates have the size and the effect of the reproductive failures. I mean, for the sperms it's caused. And for the elderly person, confirms about the Parkinson's disease. And this is the things that would be the effect of pesticides. These are pictures that from those research and look at the functions, look at the things that change with the abnormal sperms. This is since before they born. Look at this one closely to finish. From some research in Thailand that I pick up some, we found both of the pesticides and metabolite in the children, both season throughout the years. This is the research that talking about pyrethroid, the newest pesticide once used in farms, and the factors that may cause the exposures, and then these kinds of factor that we found can develop the model to prevent exposures, to reduce the concentration of exposures. That is the thing we found. And look at these pictures, the new one of my research tools in the house, in northeastern farm area, not just only chili farm. This is the flowers, plantations, and high exposures of children come from the toy surface, toy, and they play in house, and the factors and the blood choline iterate that we found is still high and found on hand, on toy, and on the wooden chairs, the things. And this is the factors. I think for the participants, you can download later on or the materials on the research papers, and or directly to request to me. And also this is the newest ones that in the farm areas that still have with the toddlers, the age of the children, still have high concentrations of pesticide is about HI index is 3. That means concentration is over the standard. 3 times is about. This is a thing that we most concerns, and in the urban settings relate with the GABAs. GABA is one of the chemicals in our bodies that relate with that. So this is the problem that it is neurotransmitters, GABAs, and have relate with the pesticide that found in households to the children's relate with the neurobehavioral as well. So that means I try to less the concern to use and more challenge in the future still have in resident of yourself or in your homes still have the pesticide use or not. If you look, if yes, still have to do with the challenge. And other location like in the workplace, you may say kids go to the workplace, no, but some kids go to the schools. You can detect, and some kinds of pesticides still have harmful to the kids. And for the pesticide exposure, like in unintentional exposures of misuse, occupational use, or in general purpose, still be a problem that have the challenge that we have to involve with the research. And this is the illness depends on the times of the effects. It's very important. We don't want to see the deaths of the kids in farms and develop some kind of disease until we see the exposures, follow-ups, some kinds of potential toxic chemical. Pesticide is always new stories. New stories forever because we develop, the scientists develop the new kinds of pesticides, need to monitor and need to introduce to the farmer to use to protect, prevent the disease. Other chemical as well, not just only pesticides, as a membership of the Lamazinis. This is a new result that mentions about the aspartame is the sweeteners can cause the cancers both in children and in humans, not just only students, but for us, and confirm very risk to the students and pregnant women should be concerned. And one of the research would be introduced from Lamasini's memberships that are talking about this. So that's all about the thing that I try to keep my time to talk to you, because when talking about challenge, is a lot of issues on challenges. Thank you very much for the time, and thank you very much to invite me to involve with your conference for today. Thank you very much.
Thank you, sir. The honor is ours. Please give a big round of applause for Dr. Watasit Siruang. Okay, now I'm going to get questions, maybe. Is there any questions from my colleagues here in the auditorium? Or maybe from the Zoom room? Is there any questions? Sir, from all of those kind of exposure, which one affect the children the most, like orally or, from the air or skin? Do you have any data about that?
Oh, yes. Because of one we use a lot nowadays. Organophosphate pesticide group, for example, like called pyrifos, still have the main problems in farms. Maybe in Indonesia also use, I heard from my colleagues, and in-house that we use every day is pyrethroids. If you look at the canned pesticides in your house, that kinds of chemicals in-house use, but it is low dose, but who knows, of the kids of exposures. The last research that I have mentioned about GABAs related with neurotransmitters that is causing from the low dose exposures. In the past, we found only the symptom like in the animal studies, but now we found in kids because we detect by the GABAs. In-house, still concerns about pyrethroids. In farms, still concerned with the organophosphate pesticide like called pyrifos and others kinds in the same groups. I think we are the same characteristics. I mean, for agricultural settings in Indonesia, I visit Indonesia many times, and 2 times include this conference is the second time of online conference. Others I visit and look at Indonesia's characteristics and farm area. Interesting, some part is still use the same pesticides, I know. So we have the same concerns. Others during COVID situations have invited to talk from Indonesian colleagues about COVID and how we setting up the agricultural system to aware of the exposure and relate with COVID issues. So that things. New pesticides is neuro effect chemicals that only concerns that things.
Okay, sir.
Yeah.
Thank you. I was watching the picture in one of your slides about the mosquito repellent spray, and the season is unpredictable, so I think almost every day a lot of households in Indonesia use that. Like, I don't know, have you ever got any tips to reduce the exposure? I mean, should we just spray it and then leave it and then we go back after 10 minutes or something? I have no idea. Do you have any suggestions?
For the spray, right? For spray repellents is, I can suggest clean the house every day, because a chance that can go on the surface of the toys and the floor is all have a chance, and all chemicals that use in house is easy to destroy even by light. Opens up the window. or you use water to clean after the sprays. That is suggestions. The suggestions. But if like you use mosquito coils, you burn it and you leave outside, and once or you think many people say it's less toxic, but you have to think that still have toxics, less but still have cleaning the floors. My last research mentions about in-house use, but we found that the way if we wear the shoe in-house is impossible. Like in Thai, we like it suggests to wear the socks, to wear the shoes in house. By the characteristic, we doesn't do like that. Like Indonesia too, we barefoot in house, right? So the ways that to suggest is clean out the floors, because it's easy to clean by the waters. If daily cleaning is good, especially for children. Because it's low dose, may have like kappa effects. The research that you can search later on and can discuss with me by emails. I have many things to talk. So I think this is my suggestion for all that you can do. Daily cleaning water is necessary because it's easy to solve with the waters. And open the shade, open the windows and let the sunlight, because those kind of chemical can easy to degrade by sunlight. Okay.
Wow.
Many people, like my colleagues and my friends, when they spray pesticide and then suddenly they close everything, because they want every insects die, but that is the thing that should not do. So to spray, after that you open for the environment to expose to the sunlight to destroy some residues. The thing I think.
Yeah, thank you, sir. That doesn't cross my mind at all. Now I have to tell my assistant to start doing that, cleaning the toys. Yeah. So do you think
clean is?
Do you
yes,
think
please.
the burning, the burning mosquito repellent or the one that using the electricity is like better?
The same.
Oh, it's the same.
The same.
Oh.
But like electricity is highly, like it continues. You plug it for 24 hours, right? So it means that you expose 24 hours. If you use mosquito coils, maybe just 10 minutes, half an hour, and you burn again, right?
Yeah.
It's not continuous.
Yeah.
It's not continuous.
Yeah, I got it. Wow. Thank you.
Tell your colleague, don't forget to close it.
Definitely,
or plug it when you are not home. When you are not at home.
Okay, sir. Thank you so
Yeah.
much. Is there any questions
Thank you.
from the audience? No questions? Zoom room? All the audience, don't forget to fill in the form in the chat, Zoom room chat, and the certificate will be emailed straight to your email. And sir, I think we have no further question yet for now, but maybe if we figured something out, is it okay if we contact you further through your emails or something?
Yes.
Thank you.
Really appreciate that all of you can email to me.
Oh, thank you so much.
Thank you for
very
the.
kind of you. I have a certificate from the committee for a while, sir. A moment. Okay, this is your certificate, sir. This certificate is presented to Associate Professor Dr. Watasid Sriwang, PhD, as the speaker in the International Webinar Society 5.0 New Challenge and Opportunity in Agromedicine. Thank you so much, sir.
Thank you. And hope to see you sometime. For everyone.
Yes, really hope to see you. Have a good day, sir. Have a good day. Okay, so I guess that's it. My duties is ended here. all of the speakers already performed their slides, and we have, I believe, me, myself, and I hope all of the colleagues here and all the participants here have a broader and wider perspective about what Society 5.0 is and what agromedicine actually can do a lot for our society. Thank you so much for the participations from everybody. Have a nice day. Assalamualaikum warahmatullahi wabarakatuh. Miss Gita.
Okay, thank you so much for Dr. Laksmi and all the speakers today. Ladies and gentlemen, the next agenda is giving certificate for our moderator today. So please, Dr. Sugianta as the chairman committee of this event, and Dr. Laksmi, come forward please, because we will take some documentation. Documentation will be start 3, 2, 1. Once again, 3, 2, 1. Okay, once more, thank you so much to all our speakers for sharing with us today, and also thanks to Dr. Laksmi for guiding today's plenary lecture. Before we step on the next agenda, we inform all participants and the audience who haven't filled out the attendance list, please access the attendance due form on Zoom chat because it's a requirement to receive your e-certificate. Ladies and gentlemen, we have now come to the end of this event. Hopefully, these events can be useful for all of us and enrich our knowledge about agromedicine and tropical diseases. Also, we would like to thank all the sponsors for supporting these events. On behalf of the entire organizing committee, we apologize if there are things that are not pleasing during the event. Thank you, and see you again in the next event. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh. Salam agromedis. All participants are welcome to leave the Zoom. Thank you.